All right, everybody. It is the fun part of the course where we start putting a little bit of interactivity into all the web pages we've been working on, and we're going to do that using JavaScript. Um, just kind of a brief overview quickly. JavaScript has really started in the mid 90s when the internet was first starting to come around. Actually, I believe it was started inside of Netscape. Brandon Ike was he had invented a toy language that he thought would be cool to implement in the Netscape Navigator browser back when everybody paid money for browsers, right? And it worked so well that Microsoft thought, hey, I'm going to copy a lot of this stuff, and they made their own version that they embedded with Internet Explorer a little bit later. This back and forth in the JavaScript history happened for about 15 years where, we were talking about jQuery the other day. Each browser did things slightly differently than the other, as we've seen, with CSS, until a standards organization came along and said, this is the actual standard for the JavaScript language, and now browsers can just follow the standard. For a while there in the 90s and early 2000s, it was the wild, wild west where everybody did things a little bit differently, and you had to get really good at writing code to cover all those different edge cases. In the context of this course, we are going to learn JavaScript in a bunch of different ways. The first of which, we're going to use it to combine with the HTML and CSS stuff we've been doing over the past couple of weeks. We're going to focus on browser-based interactions of JavaScript. So that's the traditional way JavaScript has been used, is inside of a browser. You click a button, some JavaScript runs and does some action. Later on in the course, we're going to learn JavaScript on the back end. We're going to use it as a server-side programming language so that when we submit our form, we can have JavaScript take all that information and shove it into a database somewhere. But for now, as we start to learn JavaScript, this week and next week specifically, we're going to focus mostly on the interactive side inside the browser. So how do we implement this? I'm going to pull up a project here, and we'll just show off a few different ways. So I made a week 4 file. So up till now, we've been making CSS folders. We've been making image folders, and early on we were kind of talking through some examples. It's generally a good idea to make a JavaScript folder. You can call it scripts, you can call it JS, you can call it whatever you want. When you were talking about a top-level project, it's usually going to have this kind of structure where you've got at least these 3 folders that are going to have this kind of information in it. So rather than going over all the different ways, let's just quickly make ourselves an index.html file. Right. So the first way that we want to look at is an internal JavaScript script. Right. So just like with any other metadata, we can always have a script tag that goes inside of our page here, inside the head element, and this is going to operate before any content of the page is loaded. Okay. So if I come in here and I say, alert, hello, and we'll learn about all these functions a little bit later. If I go live on this page, right, you can see that JavaScript has caused this page to give me an alert. Okay, we can put it there. It can be in the head. This would be an internal script, right? Internal, think of it as like it exists inside this page. We can also do this anywhere in the HTML, right? So we can, I can put an H1 element in here, JavaScript fun. H1. I can put this same code inside the page anywhere we want. We can have multiple script tags, right? I can say hello here, and if I reload this page, it will say hello there as well. So let's change this to hello inside body. Right? Okay. So when I reload this page, it's going to say hello inside body, exactly like our code, because it's actually embedded underneath this H1 tag, right? What is all this crazy stuff? Code injected by, okay, we're going to ignore that because that's not us. Hello inside body, and it's directly inside the body tags. And you're going to see, like this weird code that we have here, this is JavaScript, and it's telling you this was injected by the live server plugin that we're using inside of our thing. So whenever we click this go live button, this code was in here so that the plugin we're using is detecting a change in the source code and reloading the page. Okay, but this is not a part of our code. This is not our code, right? Our code is just this. So that's the one way. The other type of script that you might use is external. And so it's going to still use that same script tag, but you're going to put a source, and you're going to say JS index.javascript, right? because we have a JavaScript folder over here. So when I load this page now, right, it's going to do nothing because we took out those alerts. But if I came in here into our JavaScript folder and I made a file and I called it index.js and I say alert hello from inside the file, right? When this page loads now, it's loading that external script tag and bringing it into the context of our browser. Okay, so those are really the two main areas you're going to see it. Inside is anything that exists within the HTML document. Oftentimes that's just like with CSS when we were talking about internal styles. It's very useful for debugging. When you're inside your HTML file, you might want to just quickly write some JavaScript to make it work. But almost always you're going to have your JavaScript in a file externally. The other cool thing is, as we were kind of playing with last week, you can have multiple script tags, but these script tags can be from different locations. So what we had the other day when we were pulling in jQuery in our crazy example, let me see if I can find that real quick. jQuery CDN. Good. So you remember we copied and pasted in this code to give us access to jQuery. It's pulling JavaScript from a remote website that is hosted outside of us. So you can put any URL to any resource inside this source tag, or this source attribute from the script tag. I don't know what this integrity attribute is. Probably just letting the browser know that there was nothing changed as a man-in-the-middle attack. This cross origin equals anonymous means that we're not sending any information about our browser to that external site. But in general, this is doing the same thing as if we'd had our script tag look like this. Go ahead, Gregory. You're muted.
Sorry, my bad, mispress.
Oh, okay. So you can see here, this is our, if we ignore this stuff that was injected by the live server, we have our index.js. If I click on this, it's going to load the source code. So this is what's happening behind the scenes. Your browser, every time it gets to a tag, like an image tag, or a CSS file tag, or a JavaScript tag like this, it is making a second request to get that file and bring it in. Okay? Same with this jQuery. So when we click on this, right, this is the actual source code of the jQuery library. All of this code that has been written for us that is open source was brought into our page so that we can use it. Okay? Oftentimes when you're working in a real environment, you might start simple projects like our activity tracker or our weather tracker where, we're going to have one main JavaScript file that belongs to our web page. But then we might have extra files like when I'm on the user profile page, we're going to load a second script for that page so that I can have a profile picture, upload an avatar, or maybe I need banking information so that I can submit a credit card or a payment. You'll often use multiple script tags in every project. Okay? Any questions about how we link JavaScript or how we use JavaScript? Like this is a great example of, even though this was injected by our plugin, this is an internal JavaScript. It exists within the page. Go ahead, Andrew.
Since it has a closing tag also, does anything need to go in between, or is there any purpose for in between?
Yeah, so the in between, it does have a closing tag. The difference is if we were writing internal JavaScript, right, it would be what goes between these two tags, right? So, when we're coming here and saying alert hello from the page, inside the page, right? All of that code would go between these two script tags. When we're doing stuff externally and we're putting in a source, you should not have anything in between the two script tags because all that content is going to be pulled in from the browser. So us having this source here, right, where we've got index.js, if I'm going to click on this, what's actually happening is that the browser is smart enough to take everything that's here and dynamically pretend like it's if it was right here inside that content. So that's the same as with jQuery, right? We saw the jQuery was like hundreds and hundreds of lines. The browser goes and grabs that and puts it in here. Now, a question, I don't know the answer to this. Let's play with it, right? So we have our index file. Let's take out this jQuery one. Let's load our page, right? We have hello from inside the file. That was referenced in the thing. Can we put JavaScript inside a tag that also has a source? Alert hello second time. All right, let's see what happens. Hello from inside the file loads first, and then the stuff that's inside does not run at all, right? So you want to use either or. If you're going to put a source attribute in here and say that get all the content is coming from an external file, then if you had anything in here, this would never run. Okay. Any questions on that? This is like the fundamentals of how to get JavaScript into your browser. Is you're going to either have an external file, or you're going to have a tag itself that you can put whatever you want in. JavaScript here. Those are the two main ways. All right. Do you want to talk about the defer property? Yeah, let's talk about defer. Okay, so let's say, right, we have information in our web page. This JavaScript fun attribute, right? But up here in my heading, let's give it an ID so we can play with it. ID equals heading, right? So in JavaScript, we're going to learn about this probably at some point today or later this week. You can, the whole reason we use JavaScript is that we can use JavaScript to change data on the page. So a really frequent thing is, you'll click a button, it's going to take all the variables and store it on the server. But oftentimes you want to be able to display stuff back, like, okay, the form was successfully submitted, right? So the information, so JavaScript, we're going to use it really, really frequently to update content on the page. Now, there's one thing to be aware of, is that the elements of the page have to exist before the JavaScript can operate on it. Okay, so let's say document.getElementById, heading, right? So I'm going to get that heading element. Okay, so h1, this variable, we'll talk about variables later today. h1 has this information in it. But then let's say I wanted to do h1.innerHTML equals hello new info, right? So all this inner HTML is saying is I'm going to change the content that's inside this JavaScript where it says JavaScript is fun, replace it with hello new info, right? But the problem is, right, our hello from inside the file alerts, but JavaScript fun never changed. And that's because the JavaScript ran before that h1 element even existed. The browser is getting all of this information line by line, and as soon as it gets to the script tag is going to start operating the JavaScript before the h1 has even been sent over. Okay? So the way to get around this is a couple different ways. But the first one is if you put your code below the h1, right? Hello from inside the file, and now you can see it's silently updated to hello new info. But there's another way that you can do. So oftentimes, if you're using a library that's external, you'll often say, hey, put this not inside your head, but put this at the end of the page, right? We want to have every element exist first before the JavaScript tries to run. But there is another option, and that is called deferral, right? So very quickly, let's do defer. And does it have any attributes? No. JavaScript defer. So if we go to H3 schools, right? Defer attribute is for external script. Oh, it only works on external scripts. Shoot. Okay. So if we wanted to have this load afterwards, like our index.js script, we would have to use defer here. And if we went in here and set, because this is operated before that element existed, we can say var h1 equals document.getElementById heading. We can do h1.innerHTML equals cool content, right? So now this index.js is going to load after that other information has loaded on the page, right? So, so now you can see cool content is there because we told it to operate with defer. If we did not have defer there, this information would not update, right? Because h1 did not exist when that script tag was pulled in. Okay, so that's one of the methods. But I wanted to point that out because there are better methods to do this, and we're going to cover them later. But for the purposes of implementing the script tag, just be aware that there is an attribute called defer that will pretend as if all this JavaScript was loaded at the end. Okay. All right, let's look into the anatomy of JavaScript in general. We've been playing with this for a little bit. I'll make this a little bit bigger, right? There are a whole bunch of keywords that exist in JavaScript that are protected and tell the language what to do. So a good example of this, we've used this before, is the word var, right? Var is a keyword that says I'm doing something, okay? It tells us that we're about to create a variable. If we were to, now I'll just pull up a reference and we can go through them, kind of just give you an idea of all the different keywords that exist. And there's a bunch that we're going to cover, and there's a bunch that we're going to cover later on when we start getting into ES6. But for the purposes of like just providing an overview of the syntax and anatomy of a JavaScript file, let's pull this up. JavaScript keywords. Right? So these are all the ones that we, it's a very small language at its core, right? So abstract, arguments, Boolean, catch, continue. We'll look at each of these as they come up over the next couple of days because we really want to learn how to use them. But if you were to memorize the entirety of JavaScript, you could program any web page in any language of JavaScript using just these words. This is all you need to know. It's a very small and very simple language. Okay. But one of the things is that you cannot use these keywords as a variable name or as something that you would use inside of so var, for example, is a keyword. If I do var, right, I want to make a variable name var, this would break, and I could say Eric, right? And if we view our console here, inspect, we should actually get an error. Yeah, unexpected token var, because that keyword is a reserved word in JavaScript, and we cannot use it for naming our things. So it's important to be aware that there is a list of words that are special, and that you should not use them outside of their intended purpose. We've also played with a few different types of comments, right? So we learned about in CSS we have this style of comment where we do slash asterisk and then any number of things in here. Hello, right? This is all comment. None of this is going to be executed. JavaScript has this exact same format, right? So this is a multi-line comment in JavaScript. But one thing that JavaScript does have that is really unique is that it has a single line JavaScript, which is 2 slashes. So this is a single line comment. This is a multi-line comment. Okay? Trailing comments, I don't think that's important to cover yet. All right. There are a few other types of comments, but it's structural comments, right? So there are things that they're specific to various text editors or various things like that. We'll cover that in a later date. I don't even want to show them to you now because it seems like that would be a waste of everyone's time. Let's look at properties, right? So in JavaScript, this is considered an object, right? Anytime we have a dot here, it's accessing a property of that object, right? So when we're doing h1.innerHTML, that is saying I want to operate on the inner HTML property of the h1 object, right? So whenever we see a dot, it's almost always going to be operating on something that exists within the context of the h1 of that parent top level object. And then the other thing where we have this parentheses here, get element by ID is a property of this document object, but it's a special type of property in that it is a function. It is expecting some arguments, and it is going to do some code and provide a return to us. So in this specific example, document.getElementById, by ID, this method is returning a reference to this h1 object. We can easily show this off inside of our. Let's take this out so that our code is incorrect, right? So when we were playing around with the development console here, make this back to defer. When we were playing around with the element console here, one of the most valuable uses of this is that we can inspect all the properties and methods of these objects, right? So if I inspect this element, these are the CSS properties. It also has JavaScript properties that are attached to it that we can do things with. So when we got our h1, let's do it in here so we can play with that h1 equals, we're going to use document.getElementById heading, right? So h1 is now a property, or is now assigned to a variable that we can inspect and play with. And if we do h1 dot, and we can see all the various properties that we have the ability to touch. You're going to see the same type of list here, right? All these different methods and functions, but we can see the same type of information inside of our code editor as well, right? So, the methods are showing up as purple boxes in this example, right? But you should not get used to how it looks because you might use a different code editor in the future. The blue ones are properties that just have a value set to them. So we used inner HTML a minute ago. You can see that inner HTML is a property. It expects some value to be attached to it. ID is another one, right? So if we did ID equals new heading, right? That would be setting the ID of that property that we set in HTML in the first place to this new value. Any of these properties that are settable are going to show up as blue, and there's a bunch of them. They're often things like style elements, attributes, and then all the functions, all the things that you can do on this, where you're going to say, hey, change this to like insert HTML, insert adjacent HTML. This is going to create extra nodes, right? So the difference between methods and properties is how you access those values. Then, the other thing that it's important to note is that when we're talking about methods, right? So this get element by ID is a method. We can pass information to it, and we do that as this is called an argument or a parameter. So when we say heading, we're saying give me this element that has this value, whatever it is we're looking for. So get element by ID is a function that says find any element in this document that has the ID that has the value of heading. But we could put anything in here, right? It could be Andrew, and if we did this, right, there's no element that's called Andrew, so there it would return nothing. Oh yeah. So properties are values associated with an object. Methods are actions that can be performed on the object, and then the parameters are values passed to that method. Does everyone understand that? I think we have a good. It's not in this one. We had a good image that showed this off really well. Okay, so what are some other things that we're going to see in the language? Structural elements are very important. Let me take this out so we don't have extra stuff floating around. And really, this is just to be like. Keep in mind that this is an extremely high-level overview of the functions of the language and the syntax that you're going to see over and over and over again, so that we're talking about this over the next couple of weeks with a shared language. I'm really bad about this, where I'm bringing in names of things from different, every programming language calls things differently. So, for example, this, I call these squiggly brackets all the time. That's probably not their correct name. And in JavaScript, the correct name for this is curly brackets, right? So I should start incorporating into my vocabulary, calling them curly brackets instead of squiggly brackets. This is just a really bad habit that I have that I need to break of myself. Curly brackets, I almost caught myself doing it again, are often used for associative arrays, and we're going to learn about arrays later. They're also used as control blocks, so you might have. Let's talk about associative array first. So I can have var a equals curly brackets, and then I can have a bunch of named key value pairs. So I can say name is Eric, address, right, and then blah blah blah, right? So you'll see curly brackets used for this type of object notation. You will also see brackets like this used in control structures, so like if blocks. So if if name equals Eric, we'll use these curly brackets here to denote what happens inside this if, and you'll also see it inside any other conditions, right? So if name is not Eric, do something else, right? Okay. The other type of bracket that you're going to see pretty often is square brackets. We use square brackets for indexed arrays. We use them for a bunch of different types of arrays, but where you'll frequently find them is if we had an array called numbers, right? So this was an associative array where it had key value pairs, but numbers is just a 0 to whatever indexed array, right? So we can put anything we want here. We can be like Estrella, right? Selena, Gregory. Okay. And so Whereas with the curly bracket version of an array, we had to have, this first value is name, and the name is Eric. With this, it's just counting up from 0. So 0, 1, 2. And so if we wanted to reference this, we could say alert numbers 0, right? And that would alert Estrella on our page. So square brackets you'll see used usually with non-associative or single indexed arrays. What other language elements? Tick marks. Tick marks is an interesting one. You're going to see tick marks used for multi-line comments or multi-line strings most of the time. So right. So if I wanted this to have a bunch of lines of text, I can come in here and start typing like hello, right? Eric. Fun, right? And so everything between those two tick marks, or these tick marks, is going to be included in that multi-line comment, I believe. Yeah. Let's just verify to make sure that we're correct here. JavaScript multi-line. Oh, there's a couple ways to do it. Oh, the single tick marks. Yep. So it'll be just 1. Right? 3 is a different language. So now this is a multi-line string because we used a single backtick. And the backtick is the key that's directly next to your 1 on your keyboard to the left of it. Okay. And then the other thing that is important to be aware of is that we've kind of talked about it, but semicolons will go at the end of any single line of code, right? So the problem with JavaScript is the same problem that with HTML and the same problem with CSS is that the browser does not care about white space. So if I put var name equals Eric, right? This is perfectly valid code. The browser is going to execute this. But if I went in here and said, var if whatever equals true, right? Something, right? It's going to smush all this. It has the potential to smush all this stuff together. Okay? And so the way we denote this, we say this is the end of the line that we care about. This is the end of the single thing. Is we always want to end our information with a semicolon, right? That's going to be one of the most common problems that's going to come up. Whenever you're in doubt, it's not every line that needs a semicolon. You can see that like this array, for example, when we define this up here, we can put as much white space as we want in here. We can put, we can continue down here and say Eric. We'd say Leah, right? Because the important part is that it's held between these two things, but we've told it the array is done with this semicolon. Do you see that? Okay. Coding style, is this important to talk about? No, not yet. All right. Let's look at the console. So we've been playing with the console. Oh, come on, stop. Got too many alerts everywhere. Let's take all these out. Yep. Good. All right. Okay, let's take this out too. Let's make it defer. Oh, I changed it to Andrew, right? Okay. Perfect. All right. So the JavaScript console is going to be your best friend for exactly this reason that it tells you here, right? It is telling us that the information here, it's telling you every single JavaScript error that could exist on your page is going to pop up in the console right now. And it's also very useful. I mean, this is one of the reasons why we encourage you to use things like Google Chrome, because the tooling is extremely excellent. So this is saying there's an uncaught reference error, whatever is not defined, at line 39 of index.js. So if you click on this, it's going to actually load it up right here, right? And so what this is telling us is I used a variable in this example JavaScript code in here. If whatever equals true, whatever, we've never defined it anywhere. So this is broken. I can take this out, and now that error should go away, okay? But how would we interact with the console, right? We're writing a bunch of code. There's a bunch of mechanisms that we're going to use to do that, right? We can pull up the console, and we can see what the value of the h1, or here, let's right? So we have this var name equals Eric. I can access that variable. Let me make this a little bigger. I can access that variable inside this console at any time. So there is a var, a variable, that is named Eric, and I can come in and see that value in real time. I can also set it, so I can say, name is now Leah, right? Okay, but when the page loads from the JavaScript console, any of our JavaScript code that we've written or that we've embedded into the page, we can access from here. So I can type name again, and it's going to say Eric because I reload it. The other cool thing that we can do with this JavaScript console is that from inside of our code, we have a couple special functions that we can use. There's an object called console, and console is that JavaScript, that is that container, right? That little debugging window that we've been working with. And it has a whole bunch of methods on it that we're going to find extremely useful. The first of which is console.log, which is simply going to just write something to that console. So I can say hello from index.js, right? And when I end this, it's going to print that line in here, okay? You can have as many number of console.logs as you want, right? We could say, we can come in here and say, this is the second one, second console.log message, okay? And you see every time that page loads, information inside of our JavaScript is going to be printed out to here. You're going to use this all the time. And the biggest reason is that it's a really easy way for you to step through and debug the code that you're working on in real time, right? You're writing all this JavaScript. How do I find out what the value of the variable is, right? This is the way. You console.log it, pull up this console, and you can see like on line 40, I get this message, and on line 41, I get this message. And you can click on these, and it's going to take you into what the browser thinks that line is. Okay, it's going to show you right to where it is. What is another one we might want to use? All right, there's a few other stylistic ones. Console.warn is a good one, right? So I can say this is a warning, right? And it just shows up with a slightly different style, and it also gives us a bit of a stack trace, right? And a stack trace is just going to help us pinpoint how we got there in the first place. When we start learning about functions and stuff, this might be really good to let you know, like, how did I even get to this warning in the first place? Console.warn, it's the same kind of function, right? It's still showing us, what line of code that came from. It's showing you, but it's styled slightly differently, right? This looks like a warning. Another one that is similar to that is console.error. Right? This is an error. And this one's going to show up red. It's going to give you the same information that you get from the warning, right? So if there was a stack trace, a bunch of functions that were called to get us there, it would show you how it got to that part of the code. And we can show that. I'll show that off real quickly, just so you can have an idea of what it looks like. Make a function called warning function. Right. Console.warn. This is a warning, or warning inside a function. Right. And if I call that warning function, right? This is the warning inside our function. When we show our drop down here, it's going to tell you that on line 46 we called this function, right? Line 46 is where we actually said, hey, do this thing, and on line 49 is actually where the actual warning happened, right? So if you've got a really big complex JavaScript thing, you got a bunch of loops everywhere, this type of mechanism, both warn and error, are going to show you that full list of how you got there in the first place, okay, from start to finish. But most often, you're going to use just console.log. It's just really fast and efficient. The other thing to be aware of is that every browser, especially everyone using Chrome and Safari and Firefox, all the modern ones, they see these messages too, right? Most people browse the internet with their console closed, but all they have to do to open this up is open up the developer tools. They're going to see all of those messages, even if we built it for ourselves. So it's very important to note that just because you're console.logging or console.warning, not to put sensitive information in here, because anyone can come and see it, right? There's a couple of other cool ones, right? Console.clear, right? So we've got all that stuff. At any time, we can come in here and type console.clear, right? And it clears all that information out. You could also do that from your code, right? So we have, when we load this page, we have all these stuff. If I wanted to come in here and say, anytime there's an error, right? I could, or we called this warning function, right? We could do console.clear beforehand, so that when the page loads, all those other messages have disappeared because we want to really just focus on this one. So that might be a really useful way for, if you're using the console, for you to control, when things happen and how frequently. There's another one that's really interesting. I use this occasionally. but not as often, which would be console.time, and we give it a label. So this will be, let's put it above. So what you do is you use console.time before something happens. So we can say start, right? And then we do console.time end start, right? So the label is the important thing. And what this will do is it's going to time how long it takes for the stuff to happen in between, right? So timer start does not exist. What do you mean timer start does not exist? Console.time. Am I using it wrong? Let's follow their example. So we're going to do console.time start, and we're going to say alert, hello, right, and end, start. Let's see if this works for us. Okay. Timer start does not exist. I don't know why that's not working. All right, well, I'll play with that on our next break and see if I can make it work. I've used it before. Answer time. Yeah, they're examples. This is how it's supposed to work. Why is it not working in my browser? I don't know. All right, I don't want to spend too much time on this, but all of those console values, right? Let's try it in here. Time. Just like with all the other ones, right? It's an object. It has a bunch of different properties on it. You can scroll through this list just by typing dot and start playing with how this stuff works, right? So time in. It's all here. I don't know why it's not working. Any questions about the console stuff? This is pretty useful. You're going to use console.log all over the place, all the time. Nope. All right, on to variables. We've been using these pretty often. In original JavaScript, right, there were a few different ways to do this. So we've been playing with this a bunch of times as examples. The var keyword, right? Anything that goes after the var keyword is creating a variable that we can store content in. Now, JavaScript is a typeless language in that you do not have to declare the types of your code to begin with, right? Or the types of your variables. So var name, let's just do variable for fun, right? So variable for fun can have a string in it, right? Eric. But I could also, I'll do it from here because it'll be easy. So we have variable for fun, right? It has Eric in it. It's a string. I can also say variable for fun equals 5, right? It can be a number, right? Now variable for fun is an integer value of 5. Variable for fun can also be a float, right? So I can say this is 5.8, okay? And now the value of that is 5.8. It can also be an object, right? It can be an array, right? I could say Leah, right? And now variable for fun is an array. All of the different types of data that you're going to use on a regular basis, numbers, objects, strings, functions, they can all be shoved inside of a variable in JavaScript. And all we have to do to declare a variable in JavaScript is just say var and then give it a name, right? So name of variable. And then that's it, right? So if we declare it like this, the variable exists. If I say name of var, right, this new one we made, it's currently going to say undefined because it has no information inside of it. We haven't shoved anything in there yet. But as soon as I do name of var equals 1, right, it is now 1. Okay, there's a couple other special types that you need to be aware of. Name of var can also be true. Okay, Now it is a Boolean value. Boolean, does anyone know what Boolean means?
Like true or false?
Yeah, true or false. Great, Leah. We're going to use this all the time. One thing to be aware of is that JavaScript, because it is not a statically typed language, treats a whole bunch of things as true and as false. And I think we're going to talk about that a little bit later. So in this case, if we did if name of var, right, because we're going to use Boolean values in our if statements pretty often, right? The stuff that's in here, console.log true value, right? L, right? True value is going to be logged here because name of var is true. If I do name of var is false, and then rerun that same line of code, that same if block, nothing was displayed. But there are caveats, and we'll cover that in a brief minute. Variable name conventions. Yeah. So there's a couple things to note. We've used a few of them. If we just do var, name of var, right? This is called a declaration. We're saying this variable exists now, right? All of these variables exist inside of a top-level variable that exists on every page called window. And so window is what has all the information about the browser, the current session that you're on. And so when we do name of var, it becomes a property of name of window, right? JavaScript at its default has like a root object, and as we're doing all these variables, as we're creating functions, it's all getting shoved into that top level object, which is one of the reasons why, as we're writing JavaScript and as you're using Google Chrome, you notice that Chrome is consuming more and more memory on your computer, right? It starts to get slow as you're operating because heavy pages that have a ton of JavaScript are just shoving tons and tons of things inside of a top level object that you can access. So name of var, right, has nothing in it right now. Name has Eric because that was defined in our script, but they all exist under window. So we could do window.name has Eric. Window.name of var because has false because we made it false here. Okay. Let's make a new variable, right? We'll call it new variable, right? So if we do new variable, it's undefined. So window.newVariable, even though it exists, it's undefined. That's one of the possible states of a variable. It can be undefined, or we can intentionally set it to null, right? So we can say new variable equals null, right? So now when we do new variable, it has a null value. Null is different from undefined. Undefined means this variable doesn't exist yet. This variable has no content in it. Null is a specific setting where we're saying this intentionally has nothing in it. Okay? And then it can be true, and it can be false, and it can be a string, and it can be a number, and it can be a function. And it can be an array, an object. JavaScript is really cool in that it gives you the flexibility to just declare a variable and shove stuff into it. Now, there's a whole bunch of, you're going to want to write intentionally. You're going to want to write code that makes sense for you as the reader and other people on your team so that it makes a lot of sense. So there's a bunch of conventions, and we'll start to talk about that later on. How you name your variables is important. I tend to lean towards naming for clarity of reading. But there are other styles. Some companies will ask you to name, all of your integer variable, maybe to be like int age equals 25, right? So anytime it's going to be a number, you're going to prefix it with int, right? There is no right or wrong way because JavaScript doesn't care what you name your variables. You can have any variable name you want as long as it's not one of those reserved words like delete, right? Because JavaScript knows that delete is a special word that it has reserved for itself. There's a bunch of those, right? So we've been using new variable as our thing, but new is a keyword, right? So if I wanted to name something var new, right? Same problem. Break is another one, right? Continue. There are, this list of reserved words. These are the features of the language, right? It would be the same as if we wanted to come in here and say, I can't name something curly brace. Oh, see, it's expecting a, right? it's throwing a slightly different warning here because as soon as I put this curly brace in here, it's expecting me to finish putting an object in, right? So it's saying missing initializer in destructuring declaration. I don't know. Well, I don't know why you'd ever want to do that, but all those language features, var being one of them, var, right? We saw that as our first example. You cannot use a JavaScript specific thing. It can't be var function. That's another reserved word. But in general, the rest of the sky is the limit. You can name any variable anything you want. So always err on the side of clarity, right? A really bad practice for just about anything is single letter variables. This was something I was super guilty of when I first started programming. I'd come in here and be like var a equals, whatever, Eric, right? But a doesn't tell me what this variable is supposed to contain. It doesn't tell me anything as a programmer. If I had all of my code filled up with a bunch of letters and maybe eventually I get past 26 variables and I start making like AA, right? Our code becomes unreadable. Any questions about variable names or the structure and anatomy of variable setup, right? We learned that if you just put a name by itself, end it with a semicolon, this is a declaration. We can also declare and assign at the same time, right? So I can say var a equals whatever. So now a has that value as well. It's declared and assigned. And then if a variable exists, I can come in at any time and without using the var keyword, I can assign new information to it. So I can say now a equals Leah. And I can assign new types to it, right? So right now a is a string, but I can come in here and say a is now 5. JavaScript does not care what's in our variables. It only cares about what we name our variables if we try to use a word that it cares about. New, function, break, bar, and there are very few of them. Right? There's like, what does that look like? 4 times 15? Is that 30, 40? And we're going to learn how to use each and every one of these as we learn JavaScript. Cool. Let's talk about variable naming conventions. All right. So you've seen me mix and match. I'm particularly bad at this. There's a couple different styles. Let's just reload and get out of here. All right. Console.clear. Right. So oftentimes, short variable names is preferred over long variable names. Right. So if the variable is just supposed to be a name, I'm gonna almost say every time var name. Okay. If I needed it to be more complex than that, there's a few different stylistic ways of putting names together. The first is camel case. We've used this a few times in class. You sporadically will grab this structure. What camel case means is it's going to be a bunch of words smushed together, and every other word or every word in that smushed together word starts with a capital. So if I wanted this to be name of children, I would do var name of children. Right? This is called camel case. So that it lets us read this syntactically as saying, each of these words is meant to be different from each other. Because the alternative would be we would just use lowercase variables. If I wanted to smush multiple words together and it was name of children, right? Is that nameof, right? Words when you're smushing them together, especially if you're using complex words, sometimes it can be multiple things. Like I can't think of any ridiculous names. The other way that it could be is you might use an underscore, right? So, what is that called? Lower underscore case? Yeah. So I could do name of children, right? This is another style. Both styles are perfectly acceptable. However you want to read your code, I feel like this comes a lot down to artistic preference, right? If you think of yourself as an artist that is talking to a future programmer, how you name your variables, the only thing that matters is that you pick a style and you be consistent at this, okay? So oftentimes, my default behavior in JavaScript is that I'm going to almost always use camel case because most of the language features of JavaScript are camel case. Some of the examples that we've used as properties, inner HTML, right? That's camel case. Inner height. All of our CSS before has been dashed, right? So the CSS way to do things is max height, okay? But the problem is JavaScript had to do something different because this dash is a minus sign. So it thinks you're trying to subtract max or height from max, which would be perfectly valid JavaScript. I can come here and say var max equals 10, var height equals 5, and max height now has a value of 5 minus 10. So what JavaScript did was, because CSS is already dash prefixed, they're going to just take every dash and replace it with camel case. So in JavaScript, when we start talking about like anything that has align property, align items, justify content, it's almost always going to be the direct equivalent in CSS, but with camel case instead of that. So h1.like style align or justify content, right? This is the exact equivalent in CSS that we've been learning with justify dash content is replaced in JavaScript as camel case. So camel case in JavaScript is almost always the best way to go. But as we saw with the variable keyword, you can name things however you want, but what's generally accepted is pick a style and stick with it all the time. And the recommended way is to use camel case because it will match all the other things, right? The problem is if you picked another style like underscore, right? Like max height equals 5, right? Then you'll end up writing a lot of code that looks like h1.style.max height equals max height. And now your code kind of looks out of sync, right? Can you see that relationship there? Another thing you're going to see pretty often, the $sign. A lot of languages and frameworks use the $sign as a way to denote that this is something special to their library. jQuery was famous for this. So if we use the jQuery library, this was shorthand for like document.getElementById in a lot of frameworks. So oftentimes dot heading. We don't have jQuery in here. But you'll see stuff like this where it says, give me the element heading. jQuery actually does this as a CSS selector, so I think theirs is h1. Right? Yeah. So $h1 returns whatever you put in there as a selector. And so we can put in here and say like body. Right? It's going to return our body tag. It is important to note that some browsers, like Chrome, for example, have added this $sign in here by default. And so it is doing things that used to come directly from jQuery. So you can see how like some of these languages, especially as JavaScript has evolved, have been imported into the basics of JavaScript. But this doesn't necessarily, you might see $sign means something else. Because we can also use $sign as a way to denote that this is something important in our variable, right? We can name variables with a $sign. So I can say like name equals Eric, right? And name now is just a variable. Okay, so oftentimes when we're working on classes and libraries, it might make sense for you to denote your important functions and objects and methods by giving it a $sign at the beginning. And this is, you can get totally ridiculous with this, right? $sign is a perfectly valid name for a thing, but you can have $10 signs, right? And then it could be like equals Estrella, right? Because she likes money, right? So $, it's just a variable that has that, okay? And you can get really silly with this. You can be like name $sign. Yeah. Okay, it's just a tool in your toolbox. You're going to see it pretty frequently because there's a lot of history. jQuery being a great example. There was a previous library called Prototype that also used it. $sign is used pretty frequently, and it will be used throughout the rest of the course. So just be aware that $sign usually means pay attention to this thing because we've spent time doing it. Any questions? I think we spent a lot of time on variables, and we're really going to dive in quite a bit later, but I wanted to make sure that like the structure of variables and how they're declared before getting into the specifics of like Boolean versus so many others. Okay. All right, it is 5:56. I think now is a great time for a break before we dive into the next part of the content. Any questions before we go? No? All right, it's 5:56. Let's be back at 6:10ish. All right. I did want to, before we continue on, I figured out what was wrong with when we were trying to play with console.time. Console.clear apparently clears out everything in the console, including any timers that existed. So what I did was I commented all that stuff we had out, and then I did the same thing we were doing before, console.time, and then I put an alert in, and then I did time end. Anything you put in here is going to be the label that is used in the console when it actually shows you the value. And so what that means is it's going to say input, and it's going to tell you how much time was between the start of the timer and the time end call. Right? This is really useful for gauging some of the performance things. And we can do this directly from here as well. So we can do console.time. We can put no label, and we can say console.time end. How fast can I type? And we can see that it took me 5,000 milliseconds to type those two. From the time I hit enter to the time I hit enter on this one, that's how long it took. So be aware that if I what we were doing before, I did console.time and I put a start label in there, and then I went in here and said console.clear, which cleared out all that information. And when I did console.timeEnd start, it was telling us timer start does not exist because we just cleared it. So if you are going to use console.clear, or if you want to use any of the timing stuff, just be aware that if you cleared it between the time you started the timer and when you ended the timer, which we were doing here in our code, because we were timing how long this warning function happened, this was running console.clear, which was destroying that timer. So just be aware that that exists. Okay. Let's talk about data types. Now we've been kind of touching at this, but I think it's this is one that we really need to spend quite a bit of time on, and we're going to go over this together. So the very first thing to note is that we have a magical keyword that is called type of, and type of we're going to use inside of our code pretty often when we're evaluating values of things. But type of, whenever you put in a variable, is going to tell you what that type of the type of that variable, right? So if I do type of name equals, okay, that's a string because we know that name has Eric in it. Okay. If I did, let's say var bool, we'll say equals true, right? So bool equals true, and if we do type of here, it's going to tell us the type is a Boolean. If I do num and I say 1, and I do type of num, we get number. Okay, not integer. That is an integer, but it is a number. JavaScript behind the scenes is like abstracting away all the worry of like, is this a number? Is this a name? Is this an integer? Because we could just as easily have, let's do var, float, right? And we'll say 1.2, right? Type of float is also a number. So even though one is a float is a type of number that has decimal points, and an integer is a type of number that just has single numbers with no decimal points, right? So we have some options, some operations we can do on floats to turn them into integers, right? So if I do parse float, or parse int float, this is going to return just the top part of that float. It gets rid of all the decimal, all the extra precision, right? Oftentimes when you're doing things like rounding, right, this might be the easiest simple thing, which is just cut off all the decimals. There are other math operations that we can do on floats, like math.round. We can round up, we can round down. All the things that I'm sure you guys kind of, if you think back in your brains when you're doing like high school math, you were learning about rounding and ceilings and floors, all of that stuff we can do in JavaScript, and we're probably going to cover that mostly tomorrow. But in the context of knowing that there is a data type, numbers are things that can be integers, or they can be floats, right? So, or they can, doubles. Any type of precision is all stored in the data type of number. Okay. Now we have name here, right? It's got the name Eric. Okay. We were playing around before where we went in and said that JavaScript doesn't care what you shove in your variables, so we can come in here and say, name is now 5. Okay, and it shows us that name is 5. But because it was declared and originally assigned as a string, right? If I do type of name, it is now a string still. But JavaScript is smart enough to say, like, even though you got a number in there now, I'm going to present it as a number. We can still do number arithmetic on it. I can do like a name plus 10, right? JavaScript has now changed this to 510. Okay? It took the string 5 and it added it to the number 10 and made a new string 510. Okay? So it's very important that you use the type of to check the value, check the type of variable that you're working with. Because once you make it a string, it's very difficult to change it back to a number. There are a few things we can do mathematically here, right? So we can do, right? So name is still 5. I can do name equals name plus 10, right? That gives us 510. But I can also do, I can put a plus sign in front. And so now because I've put a plus sign in front, it has correctly turned this into name, which is 5, plus 10, 510, and this floating extra plus sign up front has changed its type, I believe, into, no, it's still a string, but it's still a string that has the correct value of the math we've done on it, okay? So strings are really crazy in JavaScript in that just about everything that can be a string, JavaScript is going to try and keep it a string forever. Now, we've played with a few of these things, parse float, right? Parse int name, right, is going to actually, if we do type of the return of this, so if I do type of here, it's going to tell us it's a number because parse int is going to return the number data type. Okay, but if we assigned that to name, we do parse int name, right? Type of name is still string because as soon as we've declared it as a string, it's going to remain a string forever. There are a few other data types that are special. We've talked about a few of them. One is undefined, right? So undefined is a thing that means it hasn't been declared. It has no value in it, right? So we can do, if I do a brand new value and I say test, right? Type of test is undefined. It's a string that says undefined. Okay. If we wanted to set this to we wanted to say, hey, this has no value. What is the data type? We talked about it briefly. Who wants to volunteer? Leah, do you know the answer? What means this intentionally contains nothing?
That's null.
Yeah, that's right. So if we did test and we say test equals null, right? Now if we do type of test, it's going to say object. Why do you think it's going to say object? We haven't really learned about objects yet, other than mentioning them. Andrew, what do you think?
Because it exists as something. It's just with the value of nothing, rather than it's not empty. It has something in it.
Correct. It's probably important to note we haven't talked about. Yeah, go ahead, Gregory.
No mind.
Okay. It's important to note, this kind of ties back to what we were talking about earlier when we were talking about window, is that in JavaScript, just about everything that is not a reserved word, right, from this list over here, is an object by default, right? So even strings are objects. Numbers are objects. Null is an object. Behind the scenes when we look at name, right? Name is a string to us, but name, just like all of our other options, has other properties, right? How can I put dot, right? So name, the object, has one thing by default, right? ToString, which returns the value, but it also has a ToFloat, which returns the ToFloat is not a function. Why does it say it's a function? If it's not a function, then you liar. ToString. So even if we were taking a look at test, which is null, and we know that it's a type of object, right? Type of test is object. Type of null is object. It's because objects have properties and methods attached to them, like we saw with string, right? Where it has a ToString function that typing and talking at the same time that does something to that object. Even our numbers, 1.ToString, right? I have to make it let's see, var num. Oh, we already have that. Good. So num.ToString is the string of 1, right? So when we're playing with 1, like behind the scenes when we're working inside the console, how it's telling us information about this when we type about it is it's always calling the toString property of the thing. If we defined a function here, let's say function Andrew is a thing that says alert hello world, right? Andrew is an object in JavaScript. Andrew.toString is the string of that function that we just had, right? It also has, a whole bunch of other magical properties and functions that may be attached to it. And the best way to find those things is whenever you've got a variable or a name here that is an object, you can always hit dot and look up. Yeah, you can see this function has arguments. This object has caller, length, right? So we can do Andrew.length, and you can see that it's 0. That same thing I think exists on string as well, right? So we can do name, right? Name.length has a value of 3 because there's 3 characters in that string, 520. If we make name Eric Harrison, name.length now will have a different return, right? A different length to it. So all things in JavaScript, from the top on down, except for reserved words, are objects, with very few exceptions. Some of these, like Boolean, for example, right? Boolean is itself an object, right? So when we've got true and false, true, right? It says it's Boolean, but toString, right, returns the string of true. So it's very important to think of like everything in JavaScript, with the exception of with the exception of the reserved words, has a bunch of magical things attached to it that you can operate on. We can also add things to this, right? So we've got numbers. So name, right? Name says Eric Harrison. I can go name dot secret equals test. Right? So now name is still Eric Harrison, but name dot secret. That didn't work. Why didn't that work? Oh, because that's the string prototype. That's advanced. We'll talk about that later. Does everyone understand that everything in JavaScript is an object for the most part, and that they all have a bunch of properties and methods, and we can do stuff with them? What are some other types? Well, we also have not a number. Not a number, you're almost always going to see. This is kind of like null and kind of like undefined in that they're a special value that we care about. They'll usually happen if you do a division by 0. So when we start getting into some of the math things that we can do, if I do, var age equals 27, okay, and we can do regular math in here just like you'd do. So I can do what's my age divided by 5, what's my age times 10, right? But if I divide by 0, that's going to give us an error every time because you can't divide by 0. So if I did age divided by 0, that gives us infinity, but that infinity is not a number. So if we assign this, so var age broken equals age divided by 0, right? Broken. Why is it saying infinity? That must be a new browser thing. Dot to int. Let's do parse int. Parse int. Yeah, there we go. So when we try to parse this int, it's telling us, for whatever reason, Chrome, this modern version of Chrome, in the console, it's saying, hey, you divided by 0, that's an infinity value. But behind the scenes, and what you might see in other browsers, Safari, Firefox, older browsers, this would always be not a number, which is the actual special data type that means like you broke math. That's when this will come up. So if you see infinity or not a number, know that you did something mathematically impossible. Can you assign not a number? Let's try that. Let's do not number. Let's say NaN. Yeah, not a number. Yeah. So not a number as a data type can also be assigned to things. If you, for whatever reason, wanted to say this is not a number, like this is broken to math. And if we did not number plus 10, right? It's going to always return not a number because you've plussed a fake number, something that has broken math with other math. Okay? So whenever you see not a number, or I guess now infinity, whenever that got added, there is something that is wrong with whatever math operations you're doing. We've been talking about all these different types of objects, right? Name is an object that has a toString method, but we can also make our own objects, right? So we were talking about this in our script example. I'm going to clear this out so we clear. Right, so we can come in here and say obj equals this, right? We can use our curly brackets to enter object mode. So an object is anything. We can create properties in here. I could say name is Eric, age is 37. I can add functions in here, so I can say toString. Right? Oh, let's show that off first. ToFun secret function. We say console.log. This is secret. Right? And we're going to close our object, right? So anything between the initial curly bracket and the end curly bracket will be a part of the variable object. So if I look at object now, you can see that it has those properties, right? It's got age 37, name Eric, it's got a secret function, and then it has a magic prototype object. This is what is actually happening behind the scenes in JavaScript that is making all of this possible in the first place. All of these objects have a prototype that inherits something from the top level. So if we looked at, we'll dive into this for sure later on, but just be aware that every object has this that tells it how to behave. So numbers have a toString that tells it how to echo on the page. All of these exist in here, right? The toString of this object is what is displaying this information to the console, right? So if we did the same thing here, object.toString, it's going to, in this case, it's going to say object, okay? Because that's the toString of this. We can come in here and we can do object.name, and it's going to display Eric, object.age, it's going to display 37, and we can also, inside of our object, call our secret function, which is going to console.log this is a secret. So is there more we want to talk about objects? So this is another data type. You're going to use this all the time. And we are going to cover objects and arrays in great detail later this week and then for the rest of the course. But we're just trying to provide a little bit of context so that we have shared terminology to discuss these things. So that when I say, tell me the properties of that object, what I'm talking about is all of the things that, all of these are the properties. Age is a property, name is a property. It's similar to CSS in that when we're defining properties there, they are defined with, height is the property and the value is 200 pixels tall. JavaScript is very similar. It was built to interact with web pages, right? The language itself was designed for the context of the web. So a lot of these things are shared concepts that you're going to see in both CSS and in JavaScript and in HTML. Okay. Let's dive into a little bit more on some of the special data types. We've talked about a lot of these, but let's do this together. So strings. We saw that strings cause us some problems when we're trying to do math against them. Okay. So very often, you saw, if we declared a number. So when we check type of number, right? Number is a number, but as soon as I say number equals 1, right? Number is now a string. JavaScript is extremely greedy at trying to turn things into strings. It assumes you want to operate with strings all the time, and so type of num now is string. And even if I wanted to go back to this being a value, right, num, if I type of num, it went back to 1. Why did it do that? Interesting. So why did name behave poorly? Type of name string. Let's do a new one. New name. Type of new name. Undefined. Good. Type of, and let's say name equals Selena. Okay. And now type of new name. Oh, I did the wrong name. Shoot. New name. Type of new name. String, correct. And if I do new name equals 5, type of new name. Number. Interesting. Why did name, when we played with it, keep it as string? Our type of name. String. If I do name equals 1, type of name. String. I honestly don't know why it's doing this. Maybe because it's a string inside of our JavaScript code. Maybe because we have it defined in here. It's, that's interesting. I've never seen this before. Let's see if Google will help us out here. So let's say google.com. Why is type of staying a string in JavaScript? Interesting. We're kind of going on a rabbit hole here, but I've never seen this behavior, and I want to make sure that we we don't tell you guys anything incorrect. Interesting. I don't know. Probably gonna have to ask someone smarter than me. Interesting. Okay. Anyway, back to where we were. So it's always important, regardless of whether or not it works in the examples when we're playing in class. You always have the type of variable here to check things, right? So we know that name is a string, even though it has the number 1 in it. Even if we, but if we assigned a new one, right? So like a test. Right, test equals 10. Test. Type of test is number. Is that strings and numbers, when you're doing math operations on them, it's not going to do math together, right? Because name, right, has the number 1 in the string. But if I do name plus test, right, it's adding those two strings together. Okay, and if we assign that to a variable, like let's do test equals name plus test. It's actually storing a string with those two things combined. JavaScript makes an effort to operate on strings whenever possible. So it's just really important to, like, if you care about it being a number, check its value first, because we do have a couple of functions that we've explored, a few of those tonight, that will force it to be and force it to operate like a string. The first is parse int, right, which says I want it to be an integer, and the other is parse float, right? So if I do parse float test now, it's going to give us 110 because it doesn't have any precision to it, but we could continue to do math on this string. Oftentimes, how this is going to come into effect is if we're working with JavaScript to gather form inputs. Right. Let's show this off as a quick example. So we've got our index here. Let's put an input, or let's do label 4 equals age. Right. We'll say age. We're going to put an input in here. We're going to say input type equals text. Name equals age, ID equals age, right? So we've given ourselves an input, right? It exists on this page. If I put 25 in here, if we get this document dot get element by ID age, right? So that is our element, right? So we have this element and we want to get its value, right? We want to get value. Right? It's the string 25. So when we're working in JavaScript, right, we're gathering user input. All of the user input, because JavaScript has no idea what this type is going to default to being a string. Okay? So if we were going to go in here and do a bunch of math and be like, you know, how old will you be in 10 years, as a silly example. If we just did el.value plus 10, okay, 2510 is not the correct answer we're trying to get here. So we always have to keep, you know, these magical values like parse float, parse int at our disposal to help us actually do what we're trying to do in a real way. So el.value, we can put this inside of a parse int, and we can say you know, plus 10, which gives us the correct value of 35. So the reason why JavaScript prefers strings over anything else is because when JavaScript was built, it assumed that you were always going to be inside of a browser and that you're going to be doing things with user input. So everything that's a user puts in is a string. So if we wanted to take this el.value, which is a string of 25, and assign that to a variable, right? If we come in here and say var real age equals el.value, real age is a string. Type of real age, string, right? So what we're going to want to do with this most of the time is when we define these, we say real age integer, right? Is we're almost always going to want to grab it as wrapped in a parse int. Parse int, which is its own standalone function. So real age integer now is actually 25, and if we check this, type of real age integer is a number instead of a string. So now we can do all the math we want all the time. In general, when you're working on JavaScript, there's a couple different ways to go about this. It's sanitizing your information, normalizing your information up front, or you can do it in your algorithm. So in this example, we're playing with an age, right? If we wanted to do some math on it and be like, how long am I going to be in 10 years? We showed off both versions of this, which would be, 10 plus parse int real age, or el.value, right? This would be doing it at the time we need it, right? The other way to do this, and this is one of the ways I prefer, which is when I'm gathering the information in the first place, I'm gonna sanitize it when I store it in my variable. So I'd say the real age integer is parse int el value, so that forever on throughout the rest of my code, I don't have to worry about this value because I've already converted it into a number. Okay, this is gonna trip you up probably 1,000 times. Almost as much as like remembering to put a semicolon at the end of your page. Just know that anything that is typed in our HTML pages by a user, anything coming from those inputs, is almost always going to be treated in JavaScript as a string, right? And you can kind of see it, right? Because the way we define strings is var name equals whatever, Gregory, right? Right. Our string is anything that goes between these quotes. Well, that is exactly the same way that we're defining this, in here, right? We say value equals 50, right? This is a string. JavaScript knows this is a string because the browser has told it this is a string, because it is defined in here as a string in our HTML. Now, could we let's take a look at one other possible education, just see what happens. So we know we have a few other input types, right? So we have input type equals number. Name equals whatever number, ID equals, let's call it num. Right, so we don't have any JavaScript silliness. Let's put a value in here. Value equals 25. Okay. Why is this red? Okay, that's fine. Oh, it's expecting me to put in a whole bunch of stuff. How can I show this off quickly? Let's see. Let's say input type number. We have an example here? Yeah, all right. Yeah, so we got a minimum, yeah. Let's put a min and max. Min equals 10, max equals 50. Right? I don't want to open that. No. Why is it not showing up on our page? Oh, because I'm missing a closing tag up here. Great. All right. So we've got a number in here, right? It has, we can reference it in JavaScript the exact same way, right? So document.get element by ID, and we say num. Right. That's going to return our element. So let's put it into EL. So EL is that input. If we do EL.value, right, even though this says 25 and we've told it it's a number field, JavaScript still treats this as a string. Okay? So each and every value that you extract out of HTML is going to be treated as a string, including, our h1, right? We have an h1 element in here. Right, if we do h1 dot inner text, right? Oh, I just typed inner text. Right, almost everything that comes out of the browser, out of our web pages, is always going to be grabbed in by JavaScript as a string. So to reiterate, like I prefer the method of as soon as I'm going to grab it, if I need this to be a number, I'm going to turn it to a number right up front, so that for the rest of my code, some of these JavaScript files you guys are going to start working with are going to be hundreds of lines long, and you're going to be passing things around into variables and things. It's almost always better, as a matter of personal preference, to do it once so that you don't have to worry about it. Any questions about that? No? All right. It's also important to note we've been talking about numbers before, right? So var num equals 1, right? These numbers can have, num, right? It's a number now. It can have, as we mentioned, decimals. I mean, let's check even to see how does it have a precision level here. Yeah. So. There is a maximum amount of precision that you can have with these numbers, right? It only went up to the second 7, so that's telling you that the data size that JavaScript supports can only support precision up to this level. So if you're talking about things in like microseconds or nanoseconds, some number that might be astronomically huge, if you care about that level of precision, you're going to have to do a bunch of interesting math tricks to get there. We can talk about those if they come up, but just be aware that numbers by default have a certain size that they can include. It is also important to note that these numbers can also be negative, right? So we can say, hey, this is actually -10, right? This can be -10 and have extra precision, right? They can be negative values, positive values, integers. They can be floats. And if we did parse int on this right now, right, it's -10 point whatever. We can do that. If we had a string, for example, that had, so var, what was that? Num equals, we're going to turn this into a string real quick, -10 or -15, whatever, right? So parse float also exists that will let you extract that information as a correct number. So parse float num, right, is similar to parse int in that it's going to actually give you a number back, but parse float will keep that precision. Whereas if we use parse int, it's going to do exactly what you'd expect, and it's going to give you -15 back. Okay, so then the same is true up here. Like we typed in, 5, 6, whatever. If I get my document.get element by ID, what was it? Age, right? Right. Dot value. It's got that string 50 point whatever we just typed in here. We could either get that as a parse int, which is going to give us 50, or parse float, which is going to give us the full shebang. Okay. You can use those pretty often, so it's important to remember that these functions exist, because especially when you're talking about dealing with user input, this is going to be pretty important when we start talking about databases and things later, and doing math on certain things. Like if we were building that activity tracker earlier, like if you wanted to count your reps and things, it's important to store those as actual numbers and to do things with it, right? So you can track over time. If we wanted to make a chart, we would want to use that as a number and not a string, so that we don't accidentally create weird, weird versions of these, like plus 25, right? Where it just tacks stuff onto the end. Cool. It's also important to note we were talking about the size of these values, right? We saw that we could do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 5, 6, 7, 8, 9, 10. Right? It's going to go just to that. It went to the 4. Okay. If we were in here, right, and we do a parse, let's say this is a string, right? So we were talking about var test equals, right? So we've got this string that has all this information in it, right? If we do parse float on this, right, it is probably going to chop off some of the precision because it went too far, right? Because we learned that JavaScript variables can only have a certain amount of precision in them. When we run parse float, it's possible that you can lose some of the data that you care about. So just be aware that that could exist. But as always, like the way to even test this and be aware of how this is going to affect your code and how your programs are going to work is that the JavaScript console is going to be your best friend, right? Like if you're working with high precision numbers, if you're console.logging this information, and all of a sudden your math starts acting weird, it's almost always one of these conversions, right? It's either you've forgot to convert a string to a number, or your number had too much precision and some of the stuff got cut off. But the interesting note is that when we're actually trying to operate on some of these numbers, sometimes the only thing you can do if you want to work on some high level of precision, like the default way to even store this is to put it as a string, because we can have a string that has any length, right? So we can do test equals 50 point. Oh, put a bunch of U's in there. Oof. Right. So test will forever hold the full value, and we just know that if we're going to do any math on this in JavaScript, we're going to have to do something else. Okay. But it's still a good way where maybe JavaScript is not the correct language to do this math, but you might want it for capturing user input. Like if you were tracking, super large numbers, or if you were working at a science facility that cared about this kind of precision, you might still build a web page that lets you input that information, and you might still display that information out of a database or show it to the users. But what you won't do is use JavaScript to operate on it. Okay? That's string and numbers. You're going to use those all the time. We talked about booleans. Booleans is true or false. Okay. We talked about undefined, where it's something has been declared but we haven't set a value to it yet. And we talked about null being us telling a variable, hey, this intentionally has nothing in it. Not a number is one of those ones that is usually when we're doing math on something that's broken. So we've covered all of those. I want to spend a little bit of time talking about Boolean, because this is one of the other things that's probably going to trip a lot of you up. Okay. So we've learned about, we're going to practice a lot more with with conditionals later. Conditionals are really, really important, right? It's stuff like if name equals Eric, right? Do something. We've played with this before. Okay? But oftentimes what we're checking with our conditionals is just whether something is true or false, right? So if we do if true, right? Console.log true, right? Real simple. And then we can do the same in reverse. If false. Okay? Nothing happened. Where this can get you in trouble is when we're checking things. So if we wanted to see, so let's say var name equals, right? So name now is an empty string. So if I do if true, let's put name in here. So name is empty. It's got nothing in it. What do you think is going to happen if we run this? Estrella, what do you think?
It won't work. It'll say undefined, right?
Not true. All right, but what I just did was I put in an else. So it's either going to say true or it's going to say not true. What do you think it's going to say?
Not true. Correct.
JavaScript was smart enough to say, hey, this is false, right? Because it's an empty string. It assumes that you don't care about the value in here, or it assumes that an empty string means not true. Let's try it with if 0. Let's do the same thing with if 0. Okay. What do you think it's going to do here? Gregory, what do you think? Are you around? Leah, how about you?
I think it'll be not true.
Okay. Exactly right. Now let's do one of the crazy ones, right? So we have, what does name say, right? Name is that. So what if we make name 0? Name, type of name, right? We know that name is a string for whatever reason, and it has a value of 0, right? So if we just do name, name is 0. But what if we do name in here now?
I think that'll be true because it's like a string and it's like going off because it's like going off like the text 0, not the actual number 0.
Exactly right. That is exactly correct. Even if we think something has a value that should be false, JavaScript is still saying this has a true value of 0. So yeah, that's exactly what you said. Because it has the string value of 0, it is true and not true, or it is true instead of not true. What are some other weird gotchas that we can catch? But the same would be if we use the, right? Like if we did parse int here, parse int name. Now, name will be not true because we've turned it into a 0, which is the same or is equivalent to a false. Okay? What about null? What if we do null? What do we think is going to happen?
I think it'll be not true. I'm not sure though. I was
we learned
wondering.
that null is an object, right? But it is not true. Why is null not true? Does anyone have a
So
guess?
what's the difference between null and 0?
A lot. 0 is a value, is a number, right? So if we do type of 0, it's a number. Type of null is an object, okay? But behind the scenes, JavaScript knows to evaluate them intentionally, right? So often you'll be more explicit, right? Because we know that, like, if I just make a undef, right? Type of undef, right, is undefined. If I do if undef, wait, let's copy our thing so we don't have to do this. Undef, right? JavaScript is smart enough to know that undefined is a not true value. But oftentimes, when you're working with user input, you will come across scenarios like, if we were up here and I don't put something in here, right? Or I put in a value that does not evaluate to not a number, right? If I put in it won't even let me type something in here. How can I describe an example? We'll just have to be on the lookout for these. But anyway, to your question of what is the difference between null and undefined and not a number and 0 and false, is that JavaScript, just by convention, knows, hey, these are the things we probably want to make false because they're things that are going to come up in our math, right? So if we were trying to say, like, maybe it's probably better and more useful to talk about that part of it when we get to looping, because that's where these are going to come up pretty often, especially when you're working with arrays and things. But we've even seen that, like, here's a great example, right? So, like, let's make an array. Var r equals Eric, Greg, Straya. Right? Okay, so we've got an array here. R 0, right? So we know our arrays are 0 indexed. But if we were working with an array like this, and we say array.length is 3, if we were talking about array.index of Eric, right? This value is 0. But JavaScript, if we were checking, does this exist within this array, right? If we wanted to say, hey, does this have the word Eric in it? Console.log true, right? This is why it's really important, right? That is going to show up as false, even though what we're actually caring about is what part of the index does this exist in, right? If I change this to Greg, right? Greg exists as index element 1, but because we're checking on a value that JavaScript by default treats as a false, we really want to say, but we really want to check for the real false value, right? So you can never have a value that's negative. Index of is going to return -1 if it doesn't have a value in there. So if I look for right? So what we have to do on our if is be aware of this and say, Eric is not equal to -1, right? So there's a whole bunch of, like, little quirks in here where you have to be aware of. Just blindly checking on the values here is sometimes dangerous. So what you often want to do is make sure that this equals undefined, or make sure that this equals -1, right? When we were playing with, what was the undefined thing we made? Undef, right? Right? So rather than just saying if undef and hoping that this is a correct way to go, right? Yep. Right? Not true. We actually want to say if type of undef equals undefined, right? So we're being explicitly extra safe on what we're checking and what we're evaluating to make sure that, like, is type of undef undefined true? Yes, but if undef ever had something else in it, if we put undef equals 1, right? If we actually thought that that should be undefined, right, then we would want to explicitly say, is this undefined or not? Okay? And the same would be true with nulls, right? We were talking about why would you want to store a null in here, right? If we said, if, what does age have in it, right? Age? Is there an age value? No. Our age equals 10, right? Age. So if I say age, let's make a new one. Var nully equals null, right? We've explicitly said this is null, but if we're trying to test it inside of our conditionals, right? This would always return as false, right? If we test this, this is not true because null is a value we don't care about. But what we really want to check is if nully equals null, right? Right? Because now it's true. Because we're comparing a value that we set that will evaluate as false, and we're saying, is this the same as the default value of null? Right? We could do the same thing with all these, right? We could say if nully equals, let's see what this does, false. Right? That's going to show up as not true, because even though behind the scenes as a Boolean, JavaScript is saying trues and false can be a bunch of different things, right? Anything that has a value is true, unless we care about the value of 0, which is also a value that we're going to get returned to ourselves. So it's very important, the best way to do this is you're going to use type of pretty often, pretty frequently, and you're going to compare it to, when you're doing your comparisons, you're going to compare it to what you think the value is supposed to be. So we would do like type of nully, right, is going to return the thing object, right? So that's why it's important. So we'd want to say if type of nully equals object, right? That's going to be true. Is everyone following along so far? Booleans are the weird one, and you can get yourself in a lot of trouble, especially with our example object where we're saying like, I want to see, does this array have the word Eric in it? Well, if Eric just happens to be in the 0 spot, now we're screwed, right? Because it says false, but Eric is very clearly in this array. And we're gonna spend a lot of time on arrays and a lot of time on objects, where we're gonna play with these quite a bit. But I think the Booleans, especially as like preparation for the conditional work we're gonna do tomorrow, it's pretty important to be aware of like some of the limitations and headaches, because this will come up, and I just want to at least make sure that we've talked about this once so that you can remember when this comes up. There's a couple of ways to find out how to like solve it, and the answer is almost always just like run type of against any variable you think needs to exist. Okay, it's going to tell you what data type it is. The one I don't understand is why name specifically. If I change this to type of name, why does it stay as a string, but all the other ones work? I don't know. That is super weird. Let's try taking it out. Let's see if we can debug this in real time. So we got it in our script here. We've declared it a bunch of places. Let's take it all out. So let's take this out. Take this out. So now we shouldn't have any name defined anywhere. Okay. Let's do var name equals Eric. Type of name. Let's do name equals 5. Type of name. Oh. I bet it's because name is a JavaScript property of HTML documents, right? So we've learned that there's a name attribute that we've been using in our JavaScript. ID is probably the same way if we used var ID equals, 10, 51, right? Type of ID number, right? If we do equals test of ID equals 10. No, I honestly have no idea why name is continuing to be. Even if we make it a number, it stays a string. That's weird. Questions? Anything you want to talk about more? Like, right now, this is just blasting information at you. It's not very interactive. It's not very fun. We can't build anything with what we've built today, other than like we can play with math a little bit. But these are the fundamentals that we are going to continue to build off of for the rest of the week, and then really going forward. Anybody have anything they want to talk about? All right. It is 7 o'clock. Now is a great stopping point for a break. We really just have one last section to cover tonight, and then we'll maybe reinforce some of the stuff from last week and see how we can start to sprinkle JavaScript into our projects going forward. So it's 7 o'clock right now. Let's come back at like 7:15 and be ready to push on to the end. Cool. While we were on break, everyone can see my screen. I was playing around with the code, right? We were trying to figure out why name kept reverting back to being this string, even though we made it an integer and vice versa. I even went so far as to take out our JavaScript. There's no word name anywhere on this page. I was viewing the page source, and then it hit me. I was here, and name is still here with name was still here with a blank value. And the reason for that is because name is a property of the window object, right? So name, it existed, like if I open a brand new tab, and I close this one, 127.0, right? On a brand new page, window.name exists. So it's already there as an empty string. This is one of those like behind the scenes browsers do this thing, and it threw me for a loop because I was declaring a variable that I thought was name, and as soon as we were turning it into a number and turning it back, it was always defaulting to a string, and that behavior did not make any sense to me. And it's because window, as we were talking about earlier, everything is an object that exists in this global browser context. Name is one of the properties that object already has. But the problem is the way variables work in JavaScript in the browser is that every time we define a variable, like a test equals hi, right? It's getting added to the window object with all these other things. So if I went down to name is there by default, just like test, right? Window.test is the exact same as that variable we just created. So when we defined a variable, the browser was smart enough to let us define it however we wanted. But then if we tried to change it to something else, it was like, I already know what name is. It's some magical property that exists behind the scenes. So I'd never noticed that before. I don't think it's ever come up because it's often like if I'm using the variable name in a real project, it's almost always going to be a string. And so I've just never noticed that there's this thing that could have happened as a weird edge case that would have caused it to not let it be a number. So it is important to know what, and a lot of this, like when we get a little bit further in and we're actually creating our own objects, when we start dealing with user input and stuff, you're probably not going to be putting things in the scope of window, right? That's anything that's at the top level. When we were talking about, loading scripts in from here, right? Script source equals index, index.js, right? Defer, right? When we're talking about any script tag that exists here, it's loading that script into the context of the window object. So any variable I make here, like var fun equals true, right? True is going into window. Okay. As we start talking about scoping, which is probably a much more advanced conversation than tonight, most of the things that you're going to be doing in here is going to be inside the context of a function. So it'd be like function test, right? So if I define a variable in here, right, it's going to be inside of that the context of text, and it's not going to go to window at all. So This is why this has never come up before for me, but it threw me for a loop as we're playing with JavaScript for the first time in this interesting kind of like made up environment where when we're really writing JavaScript, you'll probably never come across this unless you have to teach a class in the future. So just be aware that if you're ever teaching a class in the future, name already exists in Window, and that's why it's going to behave poorly when you're trying to use it as an example. All right, a couple more things. We've been talking. I've been using this all night long, and that is there are a few magical functions baked in to all of our browsers, and the first one is alert. Right, so we've been using this to do. Before the JavaScript console existed, this was like the best method for actually debugging what is the current value of this variable. So alert hello, right? It's going to pop up that little box that says hello. We used to use this all the time before the JavaScript console existed. So right, we have our variable, right? So I would do alert, test says, and then I would put in plus test, right? So this was the old method of debugging where you would use an alert like this to do this. One of the biggest challenges with alert, and when it's one of the big reasons why you should use it sparingly, is that this is blocking everything else from happening on the page. Alert, and the next two we're going to cover, prompt and confirm, is preventing future JavaScript from happening. So how would let's do a loop real quick, like for var I equals 0, I is less than 10, I plus plus. Let's not make it 10 so it doesn't go forever. Let's make this 5, right? And then if we do console.log I, right? This loop is going to loop from 0 to 5 because that's what our loop has created to do. But if we wanted to also, add an alert here, right? Alert. You see, as soon as we executed this previous loop, when we didn't have alert, it spun them out as fast as it could. But as soon as I throw alert into here, right? It prints 0 first, then it alerts 0, and it will not move on to the next line of JavaScript until I click OK. And it's going to do that each and every button press until it gets to the end of the loop, right? So alert and prompt and confirm are blocking. The term is blocking, which means it blocks the next thing happening, okay? The other one that we want to take a look at is there's one that's called prompt, right? So prompt, and I say, how are you? Right? It's going to use an alert, but it's going to let us put in input. So I can put in Eric, right? And the return of that prompt function is going to be something that we can capture. It's going to return this back to us. So we can come in here and say var my name equals prompt. How are you? Let's say, what is your name? Right? And I can say Eric. Now my name, that variable, in the right spot, my name has Eric inside of it, right? So this was one of the earliest ways of using JavaScript to capture values from users. And you'll still sometimes see this. I don't know if you guys are ever logged into some routers and some if you've got a cheap Comcast router, sometimes they'll ask for username and password in this prompt method. So they'll say prompt username, right? And then you type it in Eric, Eric. And then it'll say, as soon as it gets that, it'll say prompt password. Right? So this is a way to get user input. But bear in mind that just like with alert, this one is also blocking. So if you had this in a loop where you wanted to ask a bunch of things, it's going to prevent the rest of the JavaScript from executing. Okay. The last one I want to show off, and this one is kind of useful. I'll use this more than just about anything else, is confirm. And what confirm does is it gives you a yes or a no option, right? So I can say, do you want to leave this page, right? If I click OK, it's going to return true, a Boolean true that we can use. If I do this again, it gives us the option to cancel, which returns a false value that we can also check against. So this is super useful. If you are going to use something like this, this is a really great way to say, like, if confirm, are you sure? Right? And then, we can do console.log, he picked yes. And we can do else, console.log, he picked cancel. Right? So whatever value I click here, it's going to help that. It's going to choose which path of this if branch to go down, right? So he picked yes. I can run the same code again. Do you want to know? And it would prevent that, right? So we will use confirm sometimes. Most often if you've got like a form, right? When we were building some of these forms, if you had a big block of text and you were going to leave the page, you might write some JavaScript that says, hey, you're about to leave this page and you have unsaved work. Are you sure you want to discard it, right? And it's an OK or cancel. If you pick cancel, it would prevent that other behavior from happening. So alert, confirm, and prompt. Those are the three blocking, just built-in things. Now, there's obviously way better ways to do this. Like we've been learning about forms and stuff, right? So we can capture some user input in better ways than doing the prompt where it asks you and it pops up with the thing. But sometimes, it does have some uses and benefits in the context of building applications for the browser, right? Sometimes, a bank might use this. Hey, your session's about to time out. So that it flashes. If you're on a different tab, it would flash behind the scenes. I don't know if I can show it off easily. Set timeout. Function. Alert. Hello. Right. So I'm writing a timeout right now, which is going to do something in a few seconds. So let's say let's give it 3,000 seconds and just see what happens if we go to a different page. Right. So in 3 seconds, it's going to alert hello, but we could set this up on and go to a different page. I think this might flash. Yeah, so in Chrome, in this version of Chrome, it's showing you there's a little blue bubble here, letting you know that some activity has happened on that tab. Because if you go to that tab now, that alert shows up, right? So you might actually, if you're a banker or you're dealing with sensitive information, you might have an alert here that says, hey, you've been logged out of this website. If you click OK, it lets you know that because you're still on this, because if you didn't have that automatic log out set up, you'd still be looking at your bank account information here. And as soon as you click something, it's going to take you to the login screen, which is a jarring user behavior. It's going to feel very uncomfortable to your users. So you might want to do something like that behind the scenes that says, hey, when the timeout happens, just let them know so that when they come back to this tab, it's informing them you were logged out for inactivity, and all they click is OK. So those are 3 pretty useful built-in things, and there are better ways to do this now. Obviously, I think prompt is probably the least useful of all those, where you're asking for user input inside of an element, right? There are way better treatments for that, whether it's having a form or having some kind of pop-up that is written in HTML that looks really nice rather than being super ugly. Like if you're designing a beautiful website, this kind of user input box that only accepts one thing at a time is pretty jarring. And so if there's a use case where you'd want to do this, but by all means, just know that it's built in. But it is, there's almost always a better way to do this. Okay. All right, let's talk about math. We've been playing with this a bunch of times, right? It operates on any number, right? So when we've got numbers in here, so let's just say var num equals 10, right? Num is now a number. We can verify this with type of. Okay, so it's a number. We can do any math operation on this that we want, right? So we can do num plus 10 gives us 20. We can do num times 10 gives us 100. Num divided by 10 gives us 1, right? Because 10 divided by 10. If we do num divided by 0, we get that infinity or not a number, depending on your browser. Other interesting math things, if you wanted to do exponents, like so num to the second power. What does num have? Why would that do that? Yeah, that's interesting. Oh, that's bit shift in JavaScript. Okay, we'll cover that later. I think it's this actually. Yeah. So if you wanted to do exponents, it'd be num asterisk asterisk, right? So you could do what is the cube of what is 10 cubed, right? You could do 2, right? So it's going to give you 1,000. I don't know if factorial works. Yeah. Okay, yeah, that's for Boolean. Addition, subtraction. And you can mix and match all these things together as well, right? Like num plus 10 minus 5 times 2 divided by 3, right? And that's going to do all those operations using the commonly accepted order of operations. Do you guys remember the order of operations from your school? There's a little acronym. Does anyone remember that acronym?
Please excuse my chair, Aunt Sally.
Yep. And what does that mean, Leah?
Um. Uh. Hold on.
I can help out.
Okay.
Right. It's stuff inside parentheses, parentheticals. Right?
Oh, yeah.
Exponents, multiplication, division, addition, subtraction. So it's just talking about, if you've got a complex thing, the order of what those things happen, right? So like num is 10, right? Let's just do this with math, right? 10 plus 2 times 3, right? The 2 times the 3 is happening before the plus 10, right? It's not 10 plus 2 times 3, which would, and then parentheses come into this, because if we wanted to do 10 plus 2 times 3, that actually does that thing. The whatever's inside parentheses is always going to be first, okay? Then the exponents, right? So if it was 10, 2, right? Yep, so that's 100. But if we did 5 plus 3, right? We put this inside of parentheses, and then we did plus 10 to the second, right? So doing 10 to the second after 5 plus 3. And then multiplication followed by division, addition, and subtraction. So in that order. So it's important when you're working with math, especially in JavaScript or in any other programming language you may ever pick up, they're almost always going to follow this exact same rule, PEMDAS, right? Please, what did you say it was? Please excuse my
dear Aunt Sally.
Dear Aunt Sally.
Mm-hmm.
I love acronyms, but I'm really bad at remembering like the little cutesy bits, so I turn it into a word, so PEMDAS, right? But it's always parentheses, exponents, multiplication, division, addition, and subtraction. So those are going to happen in that order. So if you got a real long, big, complex thing, this is how it's going to, sometimes a math, 10 plus 2 times 3 is going to give you a wildly different result than, this one, 10 plus 2 times 3. 36 is way different than 16. So it's important to note that JavaScript follows that, just like you learned in, high school math or wherever they teach that. Cool. What are some other cool things we can do with JavaScript? There's another one. This one's important for figuring out remainders, right? So if we did 10 divided by 2, right, 5. Well, let's do 10 divided by 3, right? We get this 3.33333, right? So that is the actual, because it goes on for infinity, right? That you cannot evenly divide 10 divided by 3. We have a mechanism in JavaScript called modulo, which is the percent sign. Okay, so whenever you do this, it's giving you the remainder, as if you had done, 10 is divided by 3 times with 1 left over, right? So you'll use this pretty often, right? So it's the percent sign, and you can do it with any number, right? Apparently, I keep picking, yeah. So 102 divided by 7 would be 14.57, some crazy number. But oftentimes when we're talking about like the precision that you might be wanting to work with, this number probably stretches on quite a bit further, right? Because this is kind of an irrational type of number. But what you most likely want to do is be like, okay, this is actually 14. So you might even do something like this: parse int, right? You're gonna get 14, and then you might also, to build it as a string, do something like, and just know that there is a 102 modulo 7, a remainder of 4. So it goes in cleanly, 14 times, and there's 4 left over. Got it? Cool. All right, some of the other things that JavaScript will let you do. involves a specific object that was built for our benefits, and we're going to use this forever. This is going to exist on the back-end stuff as well, which is the math object. And what the math object has is a whole bunch of like higher level math functions. So if you wanted to do pi in your calculations here, rather than like typing in 3.14, you can use the shorthand math object of math.pi and get that there, right? So we could do, math.pi times 2, right? And now we have this there and available for us at all times. It also has a whole bunch of other functions that you may, like I'm not a math whiz by any means, but we were talking about math.max. So we were talking about like how do we round, how do we do these things, right? Let's do that. Math.round is probably a good first step. So if we put in here, 1.5556, right? Math.round is going to tell us it's 2. If we put in, this could be any number, right? It's rounding up to 2. But we can also talk about the precision, right? How do you get math.round? Round. Well, let's look that up. W3 Schools probably has a good resource for this. Math.round. Oh, math.round is always working up to the next integer, right? So regardless of the numbers that you put in here, it's always going to return an integer back to you, right? So this is kind of what was happening, when we were talking about like math parse int, where it's cutting off all the decimals after the end. Our other option that we have here is we could use math.round to always give us the nearest closest integer, right? So math.round, and if we made this like 1.2, right? It's gonna give us 1. So we will often use things like this, especially when talking about small numbers where we just want to get it to a range. What are some other ones that we might use? Math.floor. We put in 1.5, it's going to give us 1. Put in 1.7, it's going to give us 1. It's going to give us it's going to round down to the smallest thing that's available in that range. But if we made this like 2.7, it's going to give us 2. So it's always going to go down. Okay. We also have math.ceil, which is always going to go up, right? So if we go 2.7, it's always going to give us 3, right? It stands for ceiling. If we made this 1.7, it's going to go to 2. So ceiling goes to the next highest integer, floor goes to the next lowest integer. And then math.round is going to go, it's going to split right at that 1.5 mark, right? So math.round gives us 1.5. It's going to give us 2. If I make this 1.4, it's 1. If I make this 1.499 and repeating, it's still 1, right? Until this crosses over the 5 threshold, 1.5. Got it? What are some other important ones? Round, floor. We have the ability to quickly judge square roots, right? So if we were playing earlier with like 102 and some of these crazy numbers, right? Rather than figure out square root for ourselves, we can let the power of the JavaScript engine behind the scenes in the browser do a lot of this stuff for us. So if we wanted to do square root of 100, right, it's going to give us 10. If we wanted to do square root of 105, it's going to give us 10.2469, whatever. Like, so some of the more complicated math functions that are way more in depth, the things you normally pull out a calculator for rather than trying to figure out what the square root is in your head, that's all there for us. What else do we get? If we start working with some of the trigonometry stuff like cosine, tangent, if we care about angles between triangles, all of those exist in here as well, right? So we can play with those as well. Math.tan. So all the things that you've ever had to do in math, they exist inside this math object for us to play with, for the most part. And it's very limited, right? It's like the basic functions and shortcuts that you would need for entry-level algebra or trigonometry. If you're going to do anything more complex, right, JavaScript may not even be the right language for that, right? It is not a super fast language, especially inside the browser. But even as we get into Node in the back end, there are other libraries you'd probably want to use if you were, calculating Fourier transforms or something. Doing anything complex with even like hardcore matrix multiplication, there are better libraries that you could use rather than relying on the built-in math object. But the math object is pretty good, and it gets us pretty close, right? And you can always type it in and inspect all of the properties that are available to you. We get some logarithms. Cool. Any questions about the math object? It's pretty useful, and you will use this pretty frequently, especially some of the rounding, floor, ceiling. When we talk, when we might have a homework assignment that says like, hey, generate what is your next birthday, right, coming up, right? If you're 27 and a half months, and we're going to use the JavaScript date object to calculate the days, are you closer to your next birthday? Like, that would be an example where you'd always use ceiling. You always want to go up. Like, your next birthday is the one in front of you. And then this is super good, right? So another thing that you're going to do pretty freaking often is you're going to use math.random, right? And what math.random is going to give you is some random number between 0 and 1. It's always going to give you something between 0 and 1. I don't know why they picked that as a thing, right? Every time I hit this, it's something between 0 and 1. Now, most of the time, you want to do a random number between 1 and 100, or 0 and 100, okay? And so what you will frequently do is you'll do math.random, which is going to give you something between 0 and 1, times 100, right? And then you're going to do, math.floor, right? So now I've got something that is going to give me a random number between 0 and 100. And I can make it between 0 and 1,000 just by going like this, okay? So all the stuff that you maybe did back in the day when you were in high school or whatever, math.random will get you there real quick, right? If we wanted to pick, and how this works pretty often is if you know the amount of things in an array, right? You can randomly select one out of it by, here's a great example. Okay, var r equals, let's just put in some names, right? Why is it not letting me pick it? All right, so we got 3 names in here, right? r.length. Okay, so we can do math.random times r.length is going to give us some value between 0 and 3, right? But we actually want to do let's do math.floor that, right? So we're always going to get something between 0 and 3, right? If we'd done math.ceil, right, this could go up to 3, but we only have 3 elements in our array, and our array starts at 0 and goes to 4, right? So if we said that this math.ceil was our thing, and we wanted to say r, and then we put in this code, right? This is going to randomly pick one element out of our array. So it's going to work Estrella, and then it does undefined, which is perfect timing, because whatever it picked was the 3 value, which 3, there's no element in the 3 spot. But now it picked Estrella, now it picked Greg, right? So using math.random in combination with an array length, when you put in, if you're going to do this, you almost always want to pick floor so that it can't possibly pick the upper end of this, right? It's going to give you between 0 and whatever. So now this will never give us an undefined, and we can continue adding to our array in real time, right? We can say r.push. What else we got here? Selena. R.push. Greg. Get Greg. But let's give Gregory his full name. Oh, I don't think Andrew's in here. R.push. Andrew, right? So now our array has 6 elements, but it goes 0 to 5. But this code that we used here is basing the amount of numbers that we're multiplying against r.length, which is calculated in real time, right? So this is a super useful, you're going to do this a bunch, 100% of the time, right? Now we've just gotten a random value out of here, and it's always going to be correct. And you can see, randomness is sometimes weird. It gave us a bunch of Selenas in a row, right? You can have random things that pop out, things that's, flip a coin 10 times. You're sometimes going to get a couple of heads in a row, right? And we could do that same kind of behavior here. When we were talking about drawing cards with Leah's example, you could have an array that is, var cards, that is ace of spades, right? King of spades, right? Queen, and so on down the list. And then you could have JavaScript with this exact same thing draw cards for you one at a time. Oh, cards. Right? So this type of behavior where you're operating on arrays, you're going to use math.random and math.floor pretty frequently. You know, math.random specifically when you're trying to just get something out of the array. But math.floor when you want to make sure that the random number that you picked exists within the array. And you only get that because math.random by default is between 0 and 1. And so whatever you multiply that by is going to give you some number between that thing. Right? So math.random times 14. Right? Now it can give you values up to that level. Cool. Any questions about this? The math object is interesting. You will use it you might use it more frequently when we get into the back end stuff. But for some of the things that we've been playing with, random number pickers, you can make a bunch of games with this. You're going to need some ability to tie into randomness. So I think math.random is like one of the most useful functions in here, because it gives you the ability to like make things unpredictable. And if you can make something unpredictable, you can make something fun and joyful in what would otherwise be a website that is me clicking things around. Right? Randomness is super important. What else? Let's take a look at the W3 schools and see what they say. Yep. That's all the stuff we went over. Definitely familiarize yourself with this, right? I'm not a math wizard by any means, but if you wanted to see how these things worked, they're going to give you great, simple examples, just like all the other ones, where you can click on it and click the try it button and see this is a base 10 logarithm of the number 2. If that matters to whatever you're doing, like being able to, knowing that that's built in for you is pretty useful. So I would encourage you, if nothing else, to go through and read each of these things in case you need to use it. Oh, yeah, that's a good one. Math.absolute, you'll use this every once in a while if you just want the absolute value of something. Right? It operates on negative numbers. And it gives you whatever the... So it's going to basically take out the negative sign. Right? So if you don't know if something is negative or positive, math.absolute will change it to a positive, and now you know. And you could check, you could test this too, right? Like so, let's say we had a variable var sum num equals 112. Let's make this negative 1123.25. Okay. We've created this variable. We're gonna put it inside this function they built here. Okay, and we're gonna operate on sum num here, right? So that instead of negative 1123.25, we're getting an output of this. We could check this by saying if sum num does not equal math.abs sum num, right? You can do alert the number was negative, right? And we see that the number was negative because we compared the value of the current thing, sum num, which is negative this, against the return of math.absolute. So now we see, hey, the original starting number was negative. Can anyone just, on the basis of the things we've been learning today, is there another or perhaps a better way to check if this number is negative? We haven't really talked about the conditionals yet, but are there other ways we could check if something is a negative number? Andrew looks quizzical. What do you think, Andrew? How do I check if something is a negative number?
I was thinking with a Boolean value.
Okay. But what would I check it against? because the Boolean is going to be what this is
True.
evaluated to, right? So it's either going to be a true or false. So if we wanted to do, hey, this number was negative, can we check if some num is negative without using math.absolute? Is there like a more pure number way to do this?
If greater than or equal to 0 equals true, or
Yeah. I mean, that you're very, very close, right? So if we're just checking to see the number is negative, we would do less than 0.
or less than 0, yeah.
Less than 0, right? So if some num is less than 0, right, the number is negative. But if I change this to a positive number, right, and I click it, nothing alerts because it was already positive. So math.absolute is a really cool way for some math functions. When you just want, like, user input is a great example where it's like, I always want a positive number to come out the other end of this, and I don't trust my users to put in positive numbers. You can use something like math.absolute to force it, okay? And you can also use it to check to see if there was a negative number, but there's an easier way to check. So programming, and a lot of the things we're going to cover in this course, which we kind of talked about last week and we kind of talked about the week before, is there's about 700 different ways to do things. As long as you know that everything is possible, we can figure out ways to make the possible happen. So we could probably check if some number is less than 0 some other ways. We could probably invent a third method. Let me think. Oh, yeah, I mean, we could compare it to, we could do if greater than, right? We could do the opposite. If some number is greater than 0, then we could put it in the else, right? We can say, hey, the opposite of this is the number is negative. Right? Because whatever happens in the true path in a conditional, right, the opposite of it, we have access to the opposite using else. So if we did positive, right? So this should say this is positive, right, because the number was. But if we change this back to a negative, right, so this would maybe be a third way we can check to see if a number is negative or positive. So there's lots of different ways to approach problems. And what I would encourage you to keep in mind as we go through this course, especially as we do homework or as we start working on projects, is that each of you is going to come to problems with different perspectives. So the solution Estrella comes up with might be different than the solution Leah comes up with, but they might both be right. They might both work. Especially when we start learning about performance implications later on, right? Like, there are lots of ways to do things, and some of them are bad ideas to do them because of how inefficient they're going to run. And we'll learn about those as well, right? Like, there's some database things. The one that really kind of jumps to mind is like if you're doing subqueries. What do they call it in your course, Selena? Synchronous subqueries or something?
Correlation or
correlated subqueries. Yeah, like there is a thing you can do in a database that is like the most inefficient way to query data in the whole planet, right? But you need to know that you can do it because sometimes you might have to do it. But there are usually better ways, and usually some of those better ways is programming. So the math object has a ton of power. There's a bunch of functions in here that some of you may never use them ever, right? Like I've used some of these before, especially when building video games or doing animation before some of the animation libraries were available. If you wanted to like ease a value around the screen, we could use the JavaScript animation stuff that we learned, or the CSS animation stuff we learned last week, to have beautiful animations. But behind the scenes, what's really happening is like it's changing the top and the left values along some kind of function. If you wanted to, you could animate it yourself completely in JavaScript, but then you'd probably need to use some of these math functions to control how those numbers act behind the scenes. Okay, like a great example is if you've got this, we're dealing with percentages and stuff here, but maybe you want it to be pixel by pixel instead of 1.47 pixels, right? Like those numbers don't mean anything in CSS. We just need to move pixel by pixel. So you'd want to do math.floor or math.ceiling or math.absolute, right? Cool. All right. What's up next? Yeah, okay. I think this is probably a pretty good stopping point for today. We've covered a ton of stuff. Now, I'm happy, like, we've covered just the basics of JavaScript. Tomorrow we're going to really start diving into data models, things that you're going to use over and over again, like arrays. We're going to learn about objects, and then we'll probably start learning about conditionals a little bit more and exploring some of that. But I didn't want to like overwhelm everybody on the first day and be like, here's all of JavaScript. Okay, tonight's homework is on grids, right? So it's not even going to touch this JavaScript because you can't do anything with what we've learned yet. But what we can do with grids is it's going to be similar in style and scope to what we did with the Flexbox example. So please take your time tomorrow during lab to do that and just start digesting some of this JavaScript stuff. I'm happy to go through more examples. These are like I'm even struggling. I was mentioning to Selena today is that like because there's so much that we have to explore before we can even do things interesting that I'm having to like hand wave a bunch of stuff, and I hate doing that. Like we haven't even talked about the document object model yet, but I'm using document.getElementById so we can start interacting with pages to see how it works. So please just bear with me this week because this week is very foundational of like we've got to learn how JavaScript works, and then next week we're gonna really dive in to like how does JavaScript work in making the page do stuff, and that's when it gets really exciting. We can start building stuff together again. I'm happy to start building stuff together with again, like we were doing last week and the week before, but I don't want to like throw too much at you too quickly. So I'm really trying to like hold myself back. But if any of the things we've talked about today, strings, numbers, math, we can play with it, or we can explore some Flexbox stuff, or we can explore some CSS. What would be most beneficial? Does anybody want to cover anything specific? Estrella, what is your favorite part of JavaScript so far?
The math random actually seems really cool because
Yeah.
I was thinking it would be cool to build a website that would randomly generate story prompts.
Yes. Exactly
So
that.
that would come in handy for that.
Yep. And the thing that jumped to mind when we were playing with math.random is I have used exactly that line of code to build a card shuffler that would randomly give me cards back. Like that was Leah's little show-off project from last week. I know some of you have taken some online courses before learning some of this stuff. What is anything that we've been talking about, tonight or over the past couple weeks, more or less confusing than what you've tried learning before on your own?
Everything's definitely less confusing to me. Having like an actual person talking, it's definitely been easier.
Okay. Does anybody have anything they want us to go over again? We can play Kahoot. We can do some review. We can look at some of our projects from before. What would you guys like to do with our last hour? We could build stuff and do a show and tell again.
Is there like, do we know enough of JavaScript yet to do any like apply it at all to HTML and CSS?
Not formally, but there. I say that with a little bit. So we've learned enough to make variables. If nothing else, you should know that we can make a variable that has a reference to an element, right? We've kind of showed this off as an example, which is L equals document.getElementById. And there's actually a whole bunch of other ways you can get elements, right? There's get elements by class name, but this alone, if you come in here and you add an ID on anything like heading, right? Heading has an element already. This is going to give you a reference to that element. The other thing that we've learned here is that you can update the content of this with, we can just say l.inner HTML. And so now I could put anything I want inside this. So you can put more tag, right? Why we would use inner HTML is I might want to put extra elements in here. So I can say like, let's pick a, I'll just, for the sake of argument, do like EM, right? So we're going to make it italicized and we'd be like, Eric is fun, right? as we learned before, right, this script tag right here is happening before this h1 exists. So if we wanted to have it do it, we'd want to put it below it. But if I load our page now, why did that not work? Oh, because we did the same thing over here. Yeah. So you can see that the inner HTML element lets us put HTML in there. There is another property which is inner text, right? So that exists as well. If I put this as inner text, it would not register that tag as HTML. So it would just show up as like actual text, even though it's an HTML tag. So in general, if you know that there are these two things, inner HTML and document.getElementById, in theory, you can update any content on any page anywhere, right? We haven't learned how to like attach events so that it can happen on clicks and stuff. That's definitely more advanced than anything we've covered, and I don't want to jump ahead yet because you have to know functions and event handlers and callbacks. But we've did that answer your question? Where were you going with this? Were you wanting to know, like, could we build something with the things we've learned?
Yeah, that's what I was wondering.
Let me think. Could we build something? We could build your card picker. How about we do that? But we have it so that every time you load the page, it's going to randomly generate cards for us. All right. All right. What I need you to do, Leah. It's 8 o'clock. Do we want to take a quick break while we jump in? It's maybe 10 minutes, and then anyone need a bathroom or a drink? No?
I'm fine. I'll need
All
a
right.
break.
Cool. So, Leah, what I need you to do is you spent all that beautiful time building the building that interface. So let's start from that. If you got it checked in on GitHub, if you could paste the comment or the link to me.
Okay, sure.
I could probably find it too. But, I got your week 1 here.
It's just in my week 3 folder. Like,
Week 3.
yeah. Like cards.html and then cards.css.
All right. So what I'm gonna do is we're gonna play with her thing, your project, and we're gonna make it so that every single time you load this page, we're gonna get different cards generated. Okay. And this is an excellent example. So what I'm gonna do is I'm gonna pull up Git Bash, which is somewhere around here. There we go. And I'm gonna go. Let's close out this bad boy. We're gonna go to CD CBC 12. What? Where am I at here? Oh, on my desktop. We're gonna go to C. What the heck? I'm gonna type PW. C users me. CBC 12. All right, perfect. All right, I'm gonna go to. I'm gonna make dir. Let's do cards. Okay. I'm gonna cd to go. Well, I could just do. Yeah. I'm gonna cd to that directory. I'm gonna do git clone. Right, and then I'm gonna paste in your URL. Okay. So we got this.
I was about to do all this myself, but I realized I already have it.
Yeah, you already got it. You're ahead of the curve. Okay. All right. So let's pull this up in Visual Studio Code. So I need to open in VS Code. Cool. Let's new window. Close this one. Save. That's fine. Open folder. And cards. 3. All right. So I've got your project here open. Okay. And if we run cards.html, this is what we got. Okay, cool. So we've got cards that exist here. They look pretty good. So what we're gonna do. First, we're gonna make a jump. Here, we haven't spent much time working on branches, but I don't want my branch of code, right? If we're gonna be working in this concept of we're working together here, I want to make a new branch to add like the live editing so that you can do it as a pull request if you want it in your branch. So I'm gonna do git checkout -b, and I'm gonna say random cards. Okay. Like I'm not in the folder. Right? get checkout dash b random cards. Okay, so I'm in a brand new branch, and we can see that it updated here as well, right down here in the bottom left to let us know that we're there. So I've got your cards open, but the first thing we need to add is let's add a JavaScript folder, right? JS. Okay, and in here we're going to put cards.js. Great. So I'm going to say, let's just add some comments and some structure. So I'm going to be like, create array of cards, randomly select card 1, randomly select card 2, randomly select card 3. Okay, we're going to randomly select all 5 cards. Okay, but now what I need to do is come in here and I'm going to add this script in here. So I'm going to say script source equals js cards.js. Okay, and then I want to say defer because we're going to need some elements that exist on this page. We want to make sure that when our script loads, it's going to happen after it was there, right? We could have just as easily, I like to keep my scripts up here in the head. There's personal preference. We could have also come down here and just put it after everything was loaded, right? And that's fine too. But we're going to, for the sake of this, we're going to put it here. All right, so we've got card with an ID of 3 of clovers, 4 of hearts, 5 of spades, 6 of diamonds, 7 of spades. Now, if I had to guess, you probably made these, so we're going to have to probably come in here and see, like, how did you do this? Okay, oh, I see. You added a whole bunch of images. So what we really need to do is, where did all these come from? Do they, oh, so you went and found images each.
Mm-hmm.
Okay, so that's going to be a problem for us because we're going to have a giant list of all the images that it could be. I don't want to do that just yet, but what I do want to do is, let's just say that these cards will have this information in here, right? So, for the purposes of I'm prototyping now, I'm taking the work that you did, and I want to, right? So the card class should by itself make the card structure, right? Yeah. So I got blank cards now. Perfect. And if I wanted to test, can I put like ace spades? Right? What happens if I put some content in here? Right? I get the word, right? So that's probably good enough for prototyping purposes. Yes. All right. Cool. So we've got all these classes of cards. So what I want to do is maybe what we want to do is give these each an ID, and we say ID card 1. Right. So we can reference them by get element by ID. So I'm going to do this real quick. Right, I probably should have control clicked. But we want to have each of these IDs have to be unique. So we're going to make ID card 1, 2, 3, 4, 5. Okay. All right. So first we need to create a couple of different arrays. We're going to learn about arrays in more depth tomorrow, but we did kind of play with them today, so I'm just going to use them. There's a couple different ways to do this, right? The first would be to like actually make, a whole array of all the card possibilities. So we could do, let's do ace of spades, king of spades, right? Queen of spades, jack of spades. We do 10 of spades, right? So all the way on down the list. Or, and this is what we're really going to focus on tomorrow, we could do var suits equals spades, hearts, clubs, diamonds. Right? And then what we want to do is we're going to have a second array that is ace, king, queen, jack, 10, 9. Right? And then 8, 7, 6, 5, 4, 3, 2. So that's all the cards, right? But we want to make, and then so let's call this card values, right? So I've got two arrays, one that's got suits, one that's got card values. So we haven't learned this yet, but I think I don't want to type all this crap out 52 times. So what I'm going to do is do the quick way, which is the real way, and this is what programming is all about. So I'm going to say var cards equals an empty array like this, right? So cards is completely blank. We learned about making a blank array, but I want it to be an array. But what I'm going to do is I'm going to say for var var I equals 0, I is less than card values dot length, right? So it's going to loop between all of the values of card, ace through 2, and then I'm going to say I plus plus, okay? Then I'm going to have a second loop in here that's going to loop through suits for var s equals 0, s then is less than suits. We do s plus plus. So I've got a loop within inside a loop. Then what I'm going to do is I'm going to combine both of those values together, and I'm going to do that by saying cards dot push, right? And dot push is an array method on the array. Anything that is array has a push, a pop, a slice. We're going to talk about all that tomorrow, but all you have to need to know for now is cards dot push is going to add a value to this. And then what we're going to do is we're going to say card, because we want it to do, we're going to do card values I. So we're going to see whatever we're in right now. I'm going to add card values I plus of plus suits dot suits s, right? So this is looping through both of these arrays. It's going to loop through ace, and it's going to say ace plus spades. So it's going to say ace of spades, and it's going to go king of spades, queen of spades. So I'm going to make this big array, and if we save this now and we load our page, which should be here, right? We can go in and evaluate this in our developer console just by saying cards is all 52 of those things that we just generated with a loop. I could have also, I could have just as easily typed all that crap out myself. I could have typed in all of these things, but that seems like a pain in the butt. And we are supposed to be programmers. We're going to do things the simple way. And so we could have also, learning some of the stuff we did today, we could have, if this wasn't working for some reason, we could have tested this inside of our code by using some of the things that we were doing before, console.log. So we could have said, hey, what is card values I? Right? And when we load this page, it's going to show us what it's doing through these loops. And it's telling you that this number 4 over here just means it had that same value 4 times, right? Because it's going ace of spades, ace of clubs, ace of diamonds, ace of whatever order we typed it in, right? And then it's doing it again, but it was doing it in real time. So we could have just as easily taken this whole thing, and you'll be able to see, if I hit save real quick, watch behind the scenes here. Now it's showing us, as it's running through those loops, what is happening. And if something was wrong, if I had these backwards or something, right? If I had suits over here, right? Plus, right? Of, right? We'd be able to use this console.log mechanism to let us see what is happening inside of this very fast loop. Okay? So now we've got an array that is exactly what we want, right? It's 52. Yeah, go ahead, Andrew.
Oh, I was just gonna ask. So then, would the next step to be to do like the inner HTML?
Yep.
And then do math.random to the variable cards?
Yeah, absolutely. So let's do that real quick, because you said it exactly right. I probably, because I'm trying to write good JavaScript, I probably would do this in a function which we'll learn later on. But what we will do for the interim is, because we kind of defined it this way, let's just do this the least efficient way, like the most declarative way to write this code. So we'll say randomly select card 1. We made card 1, and we're going to say we need to get the element. So we need to do document.get element by ID card 1. Did we do card underscore 1? Gosh, I wish I followed my own rules and named things correctly. All right, cool. Card 1. Okay, so that element exists, and if I put something in here, I could do card1.inner HTML equals, test, and we can verify real quickly just by going over here. Card1 now has test in it, so that part works great. Okay, and I'm going to do the same thing for all these other cards, right? So I need to get card 2, card 3, card 4, and card 5. So quick change of root here, 2, 3, 4, and then 5. And then we have to make sure that we have the elements, the actual ID of the element as well. So you got to catch it in both places. 4, 3, 2, right? So we have all of our card elements. That's step 1. Now we want to say, hey, when we load this, we want the value, the inner HTML. We can do this really simply. We can say card1.inner HTML equals we want it to be cards and then the index, right? So if I put in here right now, if I put in 32, right, it's going to load whatever was in index 32 of that array. Right? So we're just trying to get some number between 0 and 51, right? Because even though our cards.length is 52, if I do cards 52, we're going to get undefined. So we are going to do math.floor, and then we're going to do math.random times cards.length, okay? And then we want to do +1, right? Okay. So now, every time I load this page, I'm getting a different value in here. Okay? So that part worked. Now, does anyone spot the problem that we're going to have when we generate these cards correctly? Any ideas? So I'm going to just, while you're thinking, I'm going to change all these to card 2, card 3.
They can have the same card.
Yeah. Card 5. Perfect. Yeah. Yeah, so let's just see if we can cause
Would
this
you
problem.
explain the +1 on there?
Sure. Math.random is giving you a value between 0 and 1, right? Okay. Cards.length has a 52. But we've said math.floor. So we're always going down. So we want to make sure that we can have, so maybe it's easier to show off in a, all right, so let's say we had an array, var r equals 1, 0, 1, 2, 3, 4, right? So I've got this array. Each of the array elements, just for the sake of showing this off, R0 is 0, R1 is 1, R2 is 2, right? And so on. R4, R5 doesn't exist. Okay, so if I do math.random, let's give me that, capital N, math.random, if I do times r.length, right? And I do floor, right? So the problem is this can never give us the top number, right? We're never going to get 4, right? R.length, which is 5, right? But we need to be able to get 4 out of here, and the problem is it's never going to give us 4 because it's between 0 and 1. So we're going to add 1 to the end so that that's the higher number, and then we're going to do floor so that it goes down, right?
Okay. I gotcha.
Yeah, does that make sense mathematically?
Yeah.
Okay. So yeah, exactly right. If I reload this enough times, eventually we would find we know what's going to happen, even if it takes 50 reloads. I'm not going to reload and look at this. So what we probably need to do is remove the values from the cards array when we get it. Now, do I want to cover that? Let's save that for tomorrow, because that is a perfect segue for what we can play with when we're learning about arrays. There's a whole bunch of array things like cards.push. Push puts stuff in there. We played with another one earlier, which was index of, which is like, does this exist in here? There's a few different ways we could approach this, and I don't want to get too into the weeds of like stuff we're going to cover tomorrow, because then we'll run out of things to talk about. Because we could check to see if we've picked a value that's already been picked, and if so, we could remove it when we pick it so that it's unpickable in the future, or we could check to see if we've already used it, and then recheck until we constantly, like, if I draw one that's already been drawn, draw another one until we get a good one. There's a bunch of approaches, and there's trade-offs and pros and cons with all of them. But what we've done here is like the good first step of, okay, let's make it so that we can randomly generate hands. Now, the next step for me would be, okay, let's go and find all those images so we can make these cards look correct. Or maybe we want to do this instead of using images. Maybe the next good step, if I was the designer of this project, would be to go in here and say, rather than using images, can we use CSS and maybe some of the other techniques we've learned to like, if all I got to do is make something either black or red, right? I could choose the color based on if it's right. We could, yeah. So I can make a new class in here, right? So we could do black color 000, right? And then red color red, right? And then what we can do is, whatever one we pick, right? We can come in here and we can make another type of. We learned about objects, so we can do colors, right? This is one approach. And we could say something like, spades is black. Hearts is red. Clubs, black. Diamonds is red. And then I like to line these up so that it doesn't drive me crazy. Let's make this easy on ourselves, huh? Okay, and so rather than relying on an image, I can, continuing to use JavaScript, I can decide if it is going to be a black class or a red class, and we could come in here and we'd have to capture the value of the card and see if it has spades or clubs in here, and then we could say, okay, what class do I need to apply to this element? So there's a whole bunch of stuff. As we start learning more and more of the functions of JavaScript, it'll be easy for us to start playing with and figuring out ways to change the design of what we're doing. Because we could just as easily come in here and say, like, if this was spades, for example, it gives you card 4 dot set at class name equals card 4 dot class name plus black, or let's do red. So now I've just made this font red. Learning about how to do class names like this, like that's another JavaScript thing that we're going to learn probably next week when we start talking about how do I interact with the browser, how do I interact with the HTML elements. There's just a whole bunch of things that like we've got to approach and start teaching before this. Like, we've got to learn about strings and we've got to be able to walk before we run. Does that make sense? Otherwise, we could make this super complicated, and I know what I'm doing, but you guys don't. And I think if we speed too far past this, we're going to miss important steps along the way. But maybe what I would do if I was Leah as the next step is, maybe what she does is she goes and actually finds all the images. And so rather than when we put the value in here, she just says, okay, this is the ID of this is now this variable, and then it would automatically swap to that image. Or maybe we do it with JavaScript ourselves, right? So rather than changing a CSS value, maybe all we're doing is we're saying card1.inner HTML equals, image source, whatever page.com, right? Wherever that image is actually at. So you can swap out, like, this is why you'd want to use inner HTML, because we can put HTML inside of it. Cool. I realized while I was doing this, when I was playing with the class name thing, there's an important part of strings, and it's actually an important part of the math of JavaScript that we didn't really cover today, but I don't know if we'll ever get around to it again, and it's a shorthand I use all the time, so I want to just make sure we touch on it real quick. So let's say we have a string here, and I'll just make this real big, right? Var my name equals Eric, right? So when we wanted to add stuff to this, we were playing with, messing around with seeing how the math of actually working with numbers acts kind of wonky when we're talking about strings, right? Because JavaScript wants to be nice to us, so if I do my name equals my name plus 5, right? We get Eric 5. It's actually adding this. This is called concatenation, and it's really important because I just did it with class name, which is a lot of the JavaScript values, especially as we do start to work inside the browser. Let's see. what was it? Document get element by ID, what would we call it? Card 1, right? So this has a whole bunch of attributes in here we're going to want to work on, right? So if I assign this to a variable, so I'll just do C1, right? So C1 is that element. It's a reference to the element, but it has a whole bunch of properties that exist on it that we're going to have to do things with. And one of those is class name. The problem is class name is just a string, right? And so we were playing with that string earlier. Right now it's just got one single element in there, but we know that if we were working on this in Java, in CSS, right, or inside of our HTML, if we want to add a second class to this, we would have to put a space and then that second class. So if I wanted to do red, right, now I've made it red. Well, the problem is in JavaScript, it's still just a string, right? So if I wanted to operate and add an extra class to something, I would have to do class name equals, I'd want to do c1.className plus, and then I'm adding a space so that I have a space between those things, and I would, maybe put in black. Right? So now all three of those, if we look at our HTML here, right, it worked correctly. It added card, red, black, because when I did this, I said the class name is now the class name plus this extra bit. But if I did not include that space, right, let's just make this so it's nothing right now. I've taken out card, everything is gone. And if we check that, we can see it no longer looks like a card. It doesn't do any of the cool hover effects Leah did. So generally what we'll do is we'll do C class name and we'll say card, okay? And sometimes you might want to shorthand it all together. If I know I'm going to add a bunch of classes, I might do card and red, right? So now I've applied 2 classes at once. But if I'm just adding one thing, I'm almost always going to either do this, class name, plus, and then you have to know that I'm adding a space as well. I could have just as easily done a fake space and done red, right? If my variable was, we were talking about colors before. If I did colors, spades, right? That was also equal to red. But then I would have to remember to include a plus or an extra space in there. Because if I did not, if I just did red, right? Class name, red. Now it's going to break completely because, check it out. Hang it. I'll show you. Right, so a card. Right, so it is a card. But if I wanted to add just red to it, now I've broken it because the class name says card red, which doesn't mean anything to our system, right? So when we're playing with these things, because class name is a property, whatever we set as the value of the equal sign is just going to completely overwrite everything that's in there. So the shorthand that I was talking about, right, I'm doing this whatever because I want the current value plus this new value, okay? Or I could have also done the shorthands operation, which is plus equals red, right? Plus equals is going to say whatever it is currently, take that plus this other thing. So sometimes I'll use plus equals, sometimes I'll use the full written out way, like I would do like this. Sometimes I'll do it as like plus and then a variable name, right? So there's a whole bunch of ways to skin this cat, and you need to be aware that they exist. This also works with math, right? And it's because it's not just plus, right? So let's make a number. Var num equals 10, right? I can do num equals num times 2, right? That's going to make it 20, okay? But I could have just as easily done num times equals 2. And now num has 20. I don't know if division works. Yeah, it does. And then I would imagine subtraction works. Yeah. So you can operate on your math and on your strings using this shorthand. So sometimes we'll do that, and I just want to make sure that we don't gloss over it, because who talks about addition and subtraction very often? And then the answer is nobody outside of the context of this class, right? Cool. So maybe tomorrow when we start learning about some of the arrays stuff, we'll come back to this example so we can start slicing things off. I really love working with like real concrete examples like this so that we know like why are we learning this stuff? What is it useful for? And just lecturing off slides is kind of silly to me. Anything else? What else would we like to talk about? Anything we want to go over in more detail? This first week will feel pretty slow because we're really just focusing on the fundamentals. Like, this is what the language looks like. Next week, when we start talking about the browser, then we're going to be diving in and moving stuff all over the place, changing styles, adding classes. Some of the stuff we've just kind of dabbled at here and there. But there's a whole bunch of weight. Like, there's selectors, so we can do document.getElement by class name, document.getElement by path, right? We haven't even talked about paths, really. Right? There's a whole bunch of crazy stuff that we can do. And that's just on the document level. And then once we got our things, like, we can add styles, we can add classes, we can do some magic behind the scenes to submit content to a server without leaving the page. So this week, it's really just to follow along and make sure that you ask questions when something doesn't make sense. Because a lot of the things we're going to cover is going to be contrived examples, where we just, kind of like when week 1 of CSS, we're like, let's just go to W3 Schools and play with it. Any other question? What do you got? 30 minutes-ish. Anything you want to go over? If not, I'm going to pause the recording so we have a pristine, this is what JavaScript fundamentals looks like.